Hi there, welcome to Simplilearn's YouTube channel. Imagine hundreds and thousands of rows of complex data and very little time to extract insights. Imagine a tool that helps you break this down into simple steps and help you not just extract the insights but also give you an interactive, responsive, and real time dashboard with visualizations. Yes, you guessed it right. We're talking about one such tool in data analytics, and that is none other than Power BI. And that's it. If these are the type of videos you'd like to watch, then hit that like and subscribe buttons along with the bell icon to get notified whenever we host. Also, just that you know, if you want to upskill yourself, master data science and data analytics skills, and land in your dream job or grow in your career, then you must explore Simplilearn's cohort of various data science and data analytics programs. Simplilearn offers a wide variety of master's, certifications, and postgraduate programs in collaboration with some of the world's leading universities like Purdue, IIT Guwahati, and many more. Through our courses, you will gain knowledge and work-ready expertise in skills like Python, Tableau, Power BI, generative AI, and over a dozen others. That's not all, you also get the opportunity to work on multiple projects led by industry experts working in top-tier data and product companies. After completing these courses, thousands of learners have transitioned into a data science or data analytics role as a fresher or moved on to a higher paying job and profile. If you are passionate about making your first step in this career, then make sure to check out the link in the pinned comment and description box below to find the perfect data science or data analytics program that fits your experience and areas of interest. So without further delay, let's begin. We will get started with the agenda for today's session. In today's video, we will be learning about Power BI fundamentals. Let's go through the agenda real quick. The first chapter will be about introduction to Power BI. The second chapter will be about understanding the Power BI workflow. Then the third chapter will be about connecting to different data sources. And the fourth chapter will be about data transformation with Power Query Editor. Next, we have the fifth chapter about building a data model. Sixth chapter will be about introduction to data analysis expressions. Then we have the chapter number 7, which is about visualizations in Power BI. Chapter 8 will be about real-time projects and sales dashboard. Chapter 9 will be about Power BI service, publishing and sharing reports. Then comes the chapter 10, which is about Power BI tips, tricks, and common mistakes. And the last chapter will be about certification, resource guide, and lastly, a final project to test our learnings. So I hope I made myself clear with the agenda. Now let's get started with a small quiz. Which of the following is the default file format in Power BI Desktop? The options are 1. .xlsx, second .pbi, third .pbix, and the last .cs. Please do let us know your answers in the comment section below. So let's get started with chapter 1 or module 1. So our chapter 1 will be about a quick introduction to Power BI. Welcome to module 1 of our Power BI full course. In this first session, we are going to build a strong foundation. Before we even touch the tool, we need to understand why Power BI exists, what problem it solves, and why companies in the current and in the future simply cannot operate efficiently without a strong analytics capability. Let me start with a simple but yet powerful observation. Every organization today is drowning in data. We have data coming from websites, CRMs, ERPs, IoT sensors, social media, finance systems, HR tools, literally hundreds of touch points. But the value of data doesn't come from the volume. It comes how quickly and intelligently teams extract insights from it. This is where Power BI becomes essential. Think of Power BI as the modern equivalent of a digital microscope. You point it at a raw, unorganized, messy data, and suddenly patterns start to appear. Trends become visible, anomalies stand out, and performance issues are revealed. Just like successful learners who improve rapidly by analyzing their mistakes and strengths, companies go faster when they analyze their data systematically. Power BI is not just a charting tool, it is a decision engine. And by the end of this course, you will understand how it allows individuals and businesses to transform raw data into insights that drive strategy, innovation, and growth. Now, let's go with the section 2 of chapter 1. What is Power BI? So let's go deeper. What exactly is Power BI? At its core, Power BI is Microsoft's business analytics platform, but that simple definition doesn't fully capture its capabilities. Power BI performs 4 major functions. First one, data connection. It can connect hundreds of data sources like Excel, SQL Server, APIs, cloud storage, Azure, CRM systems, Google Analytics, SharePoint, and much more. Next, we have data transformation. It includes powerful engine called Power Query that can clean, merge, shape, and prepare data through a user-friendly interface. Next is data modeling. Power BI allows you to define relationships, create DAX or data analytics expression measures, build hierarchies, and design semantic models. Data visualization and insight sharing is our next point. Finally, it enables you to present the insights using interactive visuals, dashboards, and reports. Now, here's why it matters. In traditional workflows, people often work in silos. Marketing teams prepare Excel files, finance teams use SAP or Tally exports, operations teams work on CSVs or various tools. Everyone creates dashboards independently. This leads to confusion, conflicting numbers, and zero alignment. Power BI solves this fragmentation. It creates a single version of truth. Everyone, from interns to CEOs, sees the same numbers updated in real time using the same datasets. This eliminates the guesswork, the back and forth emails, and typical who updated this file chaos. Let me give you an analogy. Think of Power BI as a GPS for business decisions. Think of Power BI as the GPS for business decisions. You provide the destination, revenue growth, and cost reduction, customer retention, and Power BI gives you the perfect route. It adapts to real time changes, helping you make informed decisions faster. This is why companies worldwide, from startups to Fortune 500 organizations, rely on Power BI for entire decision making ecosystem. Now, let's dive into the section 3 of module 1. Why Power BI matters in 2025, 2026, and beyond. Now, let's take a forward looking perspective. Why is Power BI even more important in 2026 than it was in a few years ago? Three major trends explain this. Trend number one, rise of AI driven analytics. Power BI today integrates directly with AI tools such as Microsoft Copilot, Azure Machine Learning, and AutoML. This means users don't have to manually write formulas or DAX expressions for advanced analysis. Power BI can do a lot of things. Let's discuss a few as mentioned below. First one is suggest visuals. Copilot analyzes your dataset structure and relationships, then recommends the most effective visual formats, bar graphs, line graphs, KPI cards, based on analytical best practices. This reduces guesswork and accelerates report generation. Next is summarize pages. It automatically reads all visuals on a report page and generates a narrative summary highlighting key patterns, anomalies, and correlations. This helps stakeholders grab insights without manually interpreting each chart. Then we have creating entire dashboards. By understanding your dataset and business context, Copilot can fully generate multi-page, fully formatted dashboards. It handles layouts, visuals, interactions, and defaults, making it ideal for rapid prototyping and stakeholder previews. Up next, we have explain trends. Copilot interprets real-time series data to identify rising or falling trends, seasonal patterns, and sudden spikes. It explains the why behind the changes using natural language insights grounded in statistical signals. Next ahead, we have generate DAX calculations. Instead of writing complex formulas manually, you can describe the logic in simple English, and Copilot converts it to optimized DAX expressions or measures. This is especially useful for advanced calculations like running totals, cohort analysis, and dynamic time intelligence. This shift automatically increases productivity. Non-technical users can now perform tasks that were previously the domain of data scientists. Now let's go into the trend 2. The trend 2 is all about shift to unified data architecture, which is Microsoft Fabric. So, Microsoft Fabric is becoming the core of modern analytics architecture. Power BI now integrates seamlessly with Fabric components like Lakehouse, and Power BI can directly connect to Lakehouse tables stored in one lake, enabling unified access to structured and unstructured data without complex ETL. This improves performance, governance, and cross-team collaboration. Next is data engineering. Data engineers can prepare, clean, and transform large datasets using Fabric notebooks and pipelines, and Power BI consumes these curated datasets instantly, ensuring analysts always work with high-quality, production-ready data. Followed by that, we have Data Factory with Fabric. Data factories schedule pipelines move data from multiple sources into centralized storage. Power BI then reads these refreshed datasets automatically, enabling consistent automated reporting without manual intervention. Now, the next one is real-time analytics. Power BI dashboards can stream live data from Fabric real-time analytics, or also known as Custo Engine, supporting instant insights for IoT, transactions, monitoring systems, or operational dashboards where every second counts. After that, we have machine learning. Fabric's machine learning models can score data and write predictions back into tables, which Power BI reads in real time. This enables AI-driven dashboards such as churn prediction, demand forecasting, and anomaly detection without leaving the Fabric ecosystem. This means Power BI is no longer just a visualization tool. It's a part of an end-to-end data pipeline. Now comes the trend number 3, real-time decision making. Companies want insights as they happen, not after a month and a report. Power BI supports real-time streaming data. Power BI can ingest live event streams like IoT signal, transactions, or sensor logs and update visuals within seconds. This enables operational teams to monitor activity as it happens and respond almost instantly. Next, we have direct lake connectivity. Power BI reads data directly from Fabric's OneLake in its native format, and it can bypass imports and refresh cycles. It delivers near direct query freshness with import level performance for large scale analytics. Next is auto refresh dashboards. Power BI supports scheduled and automatic refreshes, ensuring dashboards always display the latest available data. This eliminates manual updates and maintains data consistency across teams and stakeholders. For example, a logistics company can monitor vehicle movement on live. A retail chain can adjust pricing based on real time sales. A marketing team can track live performance of campaigns. Final thoughts? Power BI's importance in 2026 is not due to its charts, it's due to its speed and intelligence of insights. A business that operates with fast, consistent data insights outperforms competitors significantly. This is similar to how high performance learners constantly analyze feedback and optimize their approach. Businesses that behave similarly using Power BI achieve superior outcomes. Now comes the section 4 of Module 1, real world business applications. Understanding theory is great, but what matters is real world application. Let's look into how Power BI is used across industries, and I'll break it down by functional domains. The first one, marketing and sales analytics. Marketing teams rely heavily on Power BI for the following reasons. First one, lead generation funnel analysis, campaign return on investments, customer segmentation, revenue attribution, website and social media performance. Imagine you're running a YouTube ads campaign. Instead of manually downloading performance data, Power BI connects directly to YouTube Analytics or Google Analytics and creates a real-time dashboard showing the following visuals. So you will have a direct access to views, watch time, CTR, conversions, revenue. This allows marketing teams to optimize budgets immediately instead of losing money due to delays. The second one, finance. Finance departments use Power BI for P&L statements, expense forecasting, cash flow modeling, financial consolidation, aging analysis. The benefit is consistency. Instead of multiple Excel sheets floating around the organization, Power BI integrates everything into a single version of truth. Think of it like having an automated auditor that keeps all your numbers synchronized. Third one is HR analytics. HR uses Power BI for workforce planning, attrition dashboards, skill mapping, recruitment pipelines, diversity metrics. This helps HR leaders identify trends like which teams experience higher attrition or which skill gap can affect future growth. Now, the fourth one, operations and supply chain. For operations, Power BI acts as an operational command center. Companies track inventory analysis, manufacturing defects, supplier performance, order fulfillment times. This offers visibility from end to end, reducing bottlenecks and improving process efficiency. Now the fifth one, retail and e-commerce. In retail, Power BI is used to analyze daily sales, regional performance, product profitability, customer loyalty patterns, promotions impact, and Power BI helps these companies strategize inventory pricing and promotions. Conclusion: for this section, real-world value is what defines Power BI's credibility. Just like a learner becomes credible by consistently applying knowledge, Power BI becomes a credibility engine for organizations by delivering accurate, reliable, and timely insights. Now, the section 5 of Module 1, installing and setting up Power BI Desktop. Now let's walk through how to install and set up Power BI Desktop. Even though the process is simply straightforward, I want to explain each step and it matters. Because understanding the environment makes learning advanced concepts easier later. Step 1, which is about downloading Power BI Desktop. Navigate to powerbi.microsoft.com, like the link I've shown on the web page. Go to the download section and you can download it. The second option, however, is the Microsoft Store itself. You can go to the Microsoft Store, go to the search bar, type Power BI, and then you'll get the app. You can download it from there and install in your local system. Both the steps are valid. The Microsoft Store version updates automatically, which is convenient for beginners. But if you are the person who is looking forward to continuing with the same version for a longer duration, then the first step would be better. Now, going into this step, second, installation. Choose the 64-bit version unless your system specifically requires otherwise. Once installed, launch Power BI Desktop and wait for the interface to load. Now comes the step number 3, understanding the interface. Power BI Desktop is divided into 3 major views. First view, report view. This is where you design dashboards. Second one is the data view. This is where you inspect raw data tables. And the last one is the model view, where you build relationships, define your data model. Each view plays a critical role. In the later modules, you will notice how frequently you shift between these views as you build complex solutions. Now comes the step 4, connecting to the data sources. Power BI supports over 160 plus data connectors, including Excel, CSV, SQL Server, SharePoint APIs, web data, cloud storage, Dataverse. Even IoT data can be streamed directly into Power BI. During the installation training, we typically load from a simple Excel file like financial sample or employee data or sales data to understand how columns and data types can be detected by Power BI. Now we go into step 5. The step 5 will be about configuring settings. Key configurations include regional settings, which is important for date formats, auto recovery settings, which is important for preview features like on object interaction. Next step is about enabling Copilot if available for your tenant. These small details significantly influence your user experience. Now the conclusion. By the end of installation and setup, learners should be comfortable navigating Power BI Desktop. This foundation is essential because starting from the next module, we will dive deep into importing, Power Query, transformations, and data modeling. Now that was the end of Module 1. Now we will dive into Module 2, which is about understanding the Power BI workflow. Welcome to Module 2 of our Power BI Fill course. In Module 1, we got a complete understanding of Power BI as a tool, why it matters in 2026, and how organizations across industries depend on it. Today, now, we're going to dive deeper. This module is all about understanding the Power BI workflow, the exact step-by-step process that transforms raw, unstructured business data into meaningful dashboard that executives rely on decision making. Think of this workflow as the operating system behind the Power BI. Just as successful learners follow a structured learning path to reach mastery, successful analysts follow a structured BI workflow to create credible, reliable business insights. Now the section 1 of Module 2, understanding the Power BI workflow. Now the part 1. What is Power BI workflow? Let's start by the core idea. A Power BI workflow is the complete life cycle of your data inside the Power BI ecosystem from the moment you import the data. Here's a sharper, insight-driven version of your end-to-end analytics workflow structure, like a value chain rather than a simple sequence. This keeps it analytical, avoids marketing fluff, and clearly highlights how each stage contributes to business decisions from raw data to decisions. The complete analytics lifecycle data import, you start by pulling information from multiple sources like CRM exports, SQL databases, API, or cloud storage, ensuring the dataset represents the business data reality accurately. Next is the data cleaning. Next comes the eliminating noise step, fixing missing values, correcting inconsistencies, normalizing formats, and validating data quality. Clean data increases reliability and reduces downstream errors. Data modeling is the next step. You then define the relationships, apply business logic, and structure the dataset into meaningful views or star schemas. This step shapes how metrics like revenue, retention, or conversion rate will behave. Visualization and insight generation is the next one. With a structured model, you build dashboards, KPIs, and trend analysis that highlight patterns, anomalies, and performance drivers. This is how you transform raw metrics into intelligence. Next, we have report deployment. Reports are then published into platforms like Power BI Service, Tableau Server, or cloud dashboards, ensuring role based access, refresh schedules, and governance. Followed by that, we have decision enablement. Ultimately, these insights support strategic actions, optimizing campaigns, improving customer journeys, allocating budgets, and forecasting outcomes with data-driven clarity. Everything fits into workflow. This workflow is important because it ensures consistency, just like manufacturing industries follow a standard operation process. Data analytics team follow the Power BI workflow to maintain accuracy and speed across the reports. Now, the part 2. Why understanding the workflow is critical. Most beginners jump into visuals immediately. They drag a field, create a chart, and think that Power BI is just about visuals. But in real business scenarios, visuals represent only 20% of the work. The remaining 80% comes from data preparation. This is where raw inputs become analysis ready. It includes profiling data, handling missing values, correcting inconsistencies, standardizing formats, and shaping the data into usable structures. Good preparation reduces noise and ensures that upstream modeling remains stable. Modeling. The key goal here is to translate business logic into logical data structure. Fact and dimension tables are organized using schemas, hierarchies, calculated tables, and metric definitions mirror how the business measures revenue, performance, or customer behavior. A strong model determines the accuracy of every insight downstream. Followed by that, we have DAX. DAX is the analytical engine behind meaningful metrics. It enables time intelligence, filter, context manipulation, rolling calculations, and KPIs that behave dynamically. When models reflect structure, DAX inject intelligence, turning static data into performance driven measures. Engineering proper relations is the next step. Correct relationship ensures context flows accurately across the tables. Cardinality, direction, and granularity must align with the business process. Proper relationship engineering prevents ambiguity, avoids circular dependencies, and ensures metrics aggregate exactly as intended. Understanding the workflow helps you avoid broken dashboards. A clear workflow ensures every step, data ingestion, transformation, modeling, and visualization follows a predictable structure. This minimizes mismatched fields, broken visuals, and errors that surface when datasets change. Next is all about understanding how filter contexts go through your model prevents inflated or deflated numbers. Proper modeling plus DAX discipline ensures totals, subtotals, and KPIs reflect real business logic instead of accidental aggregations. Next, we have an important step which is about fixing performance issues. A structured workflow highlights where bottlenecks originate, heavy queries, poor relationships, unnecessary calculated columns, or non optimized DAX. It helps you diagnose and fix slow dashboards where they impact the users. Build scalable reports is our next step. When the workflow is consistent, your reports scale gracefully with new data sources, additional KPIs, or even larger datasets. A clean pipeline reduces redesign effort when businesses need to grow. Reduce refresh failures is our next step. Clear preparation and proper modeling reduce schema, mismatches, query timeouts, and dependency problems. Your data pipelines remain stable even as refresh volumes increase. Next, after that, we have create data that business teams can trust. A disciplined workflow results in consistent, predictable metrics. Team sees the same numbers everywhere, which strengthens confidence, supports decision making, and ensures your dashboard becomes the single source of truth. Basically, it helps you protect data credibility, which is the foundation of analytics. Now we enter the part 3 of module number 2, the 5 pillars of Power BI workflow. The first one, data collection. This is the starting point. Power BI connects to more than 120 plus data sources, including Excel, SQL, SharePoint, web APIs, SAP, Oracle, Snowflake, and so on. Data usually comes in different formats: flat files like .csv, operational databases, analytical warehouses, cloud platforms, streaming data sources, and a lot more. In real world companies, data is scattered. One team keeps Excel files, another has SQL databases, marketing uses a CRM, sales uses a different system. Power BI becomes a centralized platform where all these data sources converge. Now, the second one, data transformation, Power Query. This stage is one of the most important one. Think of Power Query as the data cleaning refinery. Just like crude oil cannot be used directly, it needs to be refined. Raw business data needs cleaning before it is usable. Power Query handles many important stages like removing duplicates, fixing headers, splitting and merging columns, converting formats, handling null values, replacing errors, joining tables, cleaning inconsistency, category naming, creating calculated columns, and a lot more. This stage ensures the data is trustworthy, and without trust, no dashboard is valuable. Now comes the third pillar, data modeling. This stage is where Power BI becomes the most powerful. More than Excel, data modeling is the process of structuring your data for analysis. This is the blueprint that decides how Power BI calculates numbers. Key elements include fact tables. These hold numerical, event-based data such as sales, transactions, or clicks. They represent what happened in the business and typically contain high volumes of rows. Facts drive aggregation and they are the backbone of KPI calculations. Dimension tables are the next ones. Dimension tables describe the business context like customers, products, states, regions, or employees. They enrich fact tables with attributes that help slice, filter, and segment the insights. Dimensions make reports interactive and meaningful. Star schema. A star schema places a central fact table at its core connected to multiple dimension tables. This structure improves performance, simplifies DAGs, and ensures clean filter propagation. It is the recommended modeling standard in Power BI. Relationships. Relationships define how tables connect and how filters move between them. They determine the analytical behavior of visuals and calculations. Strong, properly configured relationships eliminate ambiguity and guarantee accurate results. Cardinality. Cardinality is described as the type of relationship. There are many types of relationships: one to many, and many to one are the basic examples. The correct cardinality ensures that data aggregates properly and prevents unexpected duplication or mismatches when calculating KPIs. Cardinality. Cardinality describes the type of relation. So the types of relation can be of different ones: one to many to one, and many to many. The correct cardinality ensures the data aggregates properly and prevents unexpected duplication and mismatches when calculating KPIs. Now let's go through cross-filter directions. Cross-filter directions determine how filters flow single direction, which is the most common one, or the bidirectional one. Single direction keeps the model stable, while bidirectional is used carefully for specific scenarios like many-to-many relationships. Now let's go through DAX measures. Measures convert raw data into meaningful business metrics such as revenue, retention, or year-on-year growth. DAX leverages filter content, time intelligence, and aggregates to produce accurate dynamic calculations across reports. A strong model ensures reports run faster, numbers aggregate correctly, filters work properly. You can slice and drill down insights Companies heavily invest in modeling because it reduces conflicts such as wrong totals, duplicate counts, slow performance, and confusing visuals. Now, let's deal with visualization and storytelling. Most people think dashboards are equal to visuals, but visuals without a narrative are incomplete. Visualizations include the following: building charts, choosing the right visual type, using slicers, adding filters, highlighting KPIs, and structuring pages. Good dashboards answer business questions such as what happened. This focuses on descriptive analytics. Dashboards summarize historical performance, sales, traffic conversions, production output, or customer activity. The goal is to provide a clear, immediate snapshot of business performance without any ambiguity. Now, the next one is, why did it happen? This moves into diagnostic analytics. Power BI allows teams to drill down, segment data, compare cohorts, and analyze patterns that explain the drivers behind the results. It helps identify root causes, pricing changes, seasonal shifts, operational issues, or marketing impacts. Now, followed by this, we have what will happen next. This represents predictive analytics with features like forecasting, machine learning models, to fabric and trend analysis. Power BI helps anticipate future behavior, expected sales, customer churn, demand spikes, or risk exposure. What action should we take is the next question. This question supports the prescriptive analytics. Dashboards guide decision making by highlighting opportunities, risks, and required adjustments. Whether it is reallocating budgets, optimizing workflows, targeting profitable segments, or improving supply chain operations, insights translate directly into actions. Your goal as an analyst is to convert the data to insight and insight to action. Now comes the fifth point: publishing and sharing governance. Once the report is ready, it must be delivered to the right audience. So the right audience could be managers, sales leaders, finance heads, marketing teams, or operation teams. Power BI service enables cloud-based sharing, row-level security, data refresh scheduling, collaboration with teams, integrations with teams, Excel, SharePoint, etc. This final stage ensures business users get reliable, updated dashboards without manual effort. Now let's go to the section 2, which is about overview of Power BI desktop, service, and mobile. So the part 1 in this is about Power BI desktop. So Power BI desktop is where 90% of the analytical work happens. This is your development environment, the workshop for building analytics. Now let's go with the key functions. The key functions are data import. This is the entry point of the Power BI workflow. You pull data from files, databases, cloud systems, APIs, or enterprise warehouses. The objective is to bring raw data into the environment efficiently while preserving the structure, precision, and metadata. Next is data transformation. Using Power Query, the raw inputs are cleaned, structured, and standardized. This stage fixes errors, handles missing values, merges tables, applies business rules, and reshapes datasets. Clean transformations reduce downstream complexity and ensure consistent analytics. Now, let's go with model design. Here, data is structured into logical schema, typically fact and dimension tables. Proper relationships, cardinality, IRR, and data granularity are engineered to support accurate slicing, filtering, and aggregation. A strong model is the backbone of reliable dashboards. Now, let's go with DAX calculations. DAX converts the model into intelligence. Measures define KPIs like revenue growth, conversion rates, year-on-year performance, and operational efficiency. Good DAX respects filter context, enables time intelligence, and enforces business logics across visuals. Report creation visuals are built to communicate insights clearly. Charts, maps, tables, KPIs, slicers, and storytelling elements. Reports aim to answer business questions, highlight performance trends, reveal drivers, and support decision making through clean, intuitive design. It has a very structured interface. Now, let's go with that. The first one is the report view. This is the canvas where the insights come to life. You build visuals, arrange layouts, apply themes, and craft the storytelling layer of your dashboard. It's designed for rapid experimentation, letting you iterate on charts, KPIs, and interactions that answer business questions. Now, the second one, the data view. This view lets you inspect the transform table outputs row by row. It's used to validate common values, check data types, and verify the results of Power Query transformations. Analysts rely on it to ensure data quality, before modeling and tax creation. The last one is the model view. Here, you design the logical structure of your dataset. Tables, relationships, cardinality, filter directions are managed visually. The model view ensures your schema reflects real business processes and that metrics aggregate predictably across dimensions. The model view ensures your schema reflects real business processes and that metrics aggregate predictably across all the dimensions. Now let's discuss about the visualization pane. This pane provides full library of charts, maps, KPIs, matrices, and custom visuals. Each visual has configurable properties, formatting, interactions, data roles, conditional formatting that help turn raw data numbers into strong analytical narratives. Now, let's go into the filters pane. This pane controls all filters applied at visual, page, or report level. Proper filter usage ensures users see the right slice of data and that calculations reflect accurate context. It also helps fine-tune interactivity, comparisons, and scenario exploration. Now, let's go with the data fields pane. This lists all tables, columns, and measures in your model. It's the core workspace for dragging fields into visuals, building new measures, controlling hierarchies, and managing calculated fields. A well-organized fields pane accelerates reporting efficiency. Analysts spend most of their time here because this is where insights are engineered. Power BI Desktop is free. This makes it accessible to students, beginners, and companies of all sizes. Now comes the part 2, Power BI Service. Power BI Service is the cloud platform. Once reports are ready, they are published here. Its key features include creating dashboards, managing workspaces, scheduling data refresh, viewing reports online, organizing analytical assets using the Power BI app, embedding reports into websites, row-level security, and collaboration in Workspace. In 2026, Power BI Service is deeply integrated with Microsoft Fabric and Microsoft Copilot. Microsoft Fabric brings data engineering, data science, real-time analytics, warehouse workloads, and lakehouse architecture, all inside the same environment. This makes Power BI a front end for entire modern data stack. Now let's go through the part 3, Power BI Mobile. The third component is the Power BI Mobile. This is crucial for decision makers who are always on the go. Executives want quick snapshots, alerts, sales performance, market trends, and operational bottlenecks on the go. Power BI Mobile allows them to monitor business performance in real time. Many companies rely on mobile dashboards during morning sales stand-ups, weekly reviews, executive board meetings, and many more. Together, the desktop, service, and mobile form a complete ecosystem. Now, let's dive into the section 3. Typical workflow explained with some examples. So let's consider an example. Retail chain with 50 stores. Let's look at a practical example. You're a business analyst for a retail company that has 50 stores across the country. Now the management wants a dashboard showing daily sales, category-wise performance, store revenue, and top-selling products. Now let's walk step by step through how you build it. Step 1. Connect to data. You connect to Excel for daily sales, SQL Server for inventory, CSV export from POS. Power BI combines all these 3 data sources seamlessly. Step 2. Clean the data. In Power Query, you fix the category mismatches, remove duplicates, correct date formats, merge store metadata, handle missing values. You ensure that the data satisfies real-world business logic. Now comes the step 3. Build the data model. You create a star schema, fact sales, dimension product, dimension store, dimension date. You establish relationships. Then you write DAX measures like total sales, profit margin, average basket, size, year-on-year growth. Now, the model can answer the business questions almost instantly. Now comes the step 4. Build the report. Your dashboard includes a line chart for monthly sales, a bar chart showing category contribution, a geographical map showing store performance, KPIs highlighting revenue tables, listing top products, filter for store, category, and date. Users can now drill down from total sales to city to store to product. Now, let's dive into the step number 5. Publish the report. Power BI Service is your option. You can publish the report, then you set frequency, define permissions, create dashboards, distribute to leadership teams. Now, the entire organization uses your dashboard. Now with that, let's dive into the section 4, key components of Power BI interface. The first one, ribbon. This includes home, insert, modeling, view, and help tabs. Each controls a different part of the workflow. The second one is the views pane. This includes report view, data view, and model view. Each view offers different angle of analysis. The third one is the fields pane. This shows tables and fields. A well-structured field pane improves efficiency. The fourth one is the visualization pane. This is where you select charts, customize visuals, change colors, enable analytics lines, and format your visuals. Now the fifth one is the filters pane. Filters allow control over what data appears on the report page or a visual. Then comes the sixth one, which is canvas area. This is where visuals come together and form a meaningful story. And with that, we have finished the module 2, and now we make a transition to the module 3, which is based on connecting to data sources. Next comes the filters pane. This pane controls all filters applied at visual, page, or report level. Proper filter usage ensures users see the right slice of data and that calculations reflect accurate context. It also helps fine-tune interactivity, comparisons, and scenario exploration. The data fields pane is the next one. This pane lists all the tables, columns, and measures in your model. It's the core workspace for dragging fields into visuals, building new measures, controlling hierarchies, and managing calculated fields. A well-organized fields pane accelerates report efficiency, and analysts spend most of their time here because this is where insights are engineered. Power BI Desktop is free. This makes it accessible to students, beginners, and companies of all sizes. Now comes the part 2, Power BI Service. Power BI Service is the cloud platform. Once reports are ready, they are pulled and published here. Its key features include creating dashboards, managing workspaces, scheduling data refresh, viewing reports online, organizing analytical assets using the Power BI app, embedded reports into websites, row-level security, collaboration in workspace. In 2026, databases, cloud services, real-time streaming systems, APIs, big data engines, enterprise solutions, Microsoft Fabric and Azure resources, and a lot more. Data connectivity is the backbone of every Power BI solution. And in this module, you'll understand not only how to import data, but also why certain methods are chosen in real-world business environments. Now, the section number 2 is about importing data from Excel. Let's begin with the most common and beginner-friendly data source, which is Excel. Excel is still one of the most used analytics tool in the world, making the perfect start point. How to import Excel data? You can open the Power BI dashboard, go to Home, Get Data. So browse and select your file. Power BI displays the Navigator window showing available sheets and tables. Don't worry, this is just a quick theoretical approach. Once this is done, we will be directly diving into the demonstration mode where we'll practically explore all these. Now, once you see the available sheets and tables, select the required items and click Load or Transform Data based on your request. Repeat. And click on Load or Transform based on your requirement. Then comes the important concepts. If your Excel file uses names, tables, Power BI treats them as clean structured objects. If your Excel file uses plain ranges or messy layouts, Power BI still imports them, but you will need Power Query to clean them later. Now, business relevance. Excel is widely used for monthly sales reports, budget, financial transactions, campaign tracking, ad hoc department level reports. This means data analysts frequently integrate Excel with larger systems like SQL Server, CRM data, and a lot more. Now let's also discuss some common issues and best practices. Ensure the first row contains column names. Avoid merged cells. Power Query struggles with them. Keep date formats consistent. Try to use tables instead of raw ranges. Now let's go through an analogy. Think of Excel data as manually entered at department. Now let's go through an analogy. Think of Excel data as manually entered or department level data, like a student's personal note. They help with context, but they often require polishing before being shared. Now let's go through the section 3, which is about importing CSV data. CSV files are often another common data source, especially for exports from applications, websites, or tools. Now, how to import CSV? The same. Go to Home, Get Data, then you choose Text or CSV option. Select your CSV file. Power BI automatically detects column delimiters and data types. It also shows you a preview. Click on load or transform data based on your requirement. Why CSV is important? CSV is a universal format used across marketing platforms like Facebook ads, Google ads, e-commerce reports, CRM systems, ERP exports, social media analytics, automation tools, payment gateway logs. CSV files are lightweight, system friendly, and easy to automate. Now, let's go through some key differences between Excel and CSV. CSV does not support formulas, no formatting, no multiple sheets, faster for automation and ETL pipelines. So basically, every CSV cannot be Excel, but Excel can be turned into a CSV. Now, let's go through some best practices. Treat CSV files as raw system output. They usually require data cleaning but ensure more consistency because they don't contain any formatting errors. Now let's dive into section 4, which is about connecting to web sources. So next we explore one of the most powerful features, which is web data sources. Power BI can connect directly to websites or APIs and fetch structured data. Go to the Get Data option, enter the URL by choosing the web option. Power BI loads the HTML or JSON content. Select the required table or hierarchy, transform it and load it. For example, extracting stock market data or pulling cryptocurrency prices or getting live COVID-19 data, weather statistics, reading product listings, import government datasets, and a lot more. You can also go with API-based data like YouTube Analytics or Google Maps data and a lot more. Now let's also discuss a small use case. Imagine a company that wants daily currency conversion rates. Instead of manual downloads, Power BI can fetch real-time rates through a web API and keep dashboards always current. Now a small keynote, when using APIs, authentication may be required. API keys, tokens, OAuth, etc. Now let's also go through an analogy. Web data is like tapping into a live knowledge source. Similar to how learners use online platforms to stay updated instead of static files. You get dynamic, evolving information. Now let's go through the section 5, which is about connecting to databases. This section covers the enterprise grade side of Power BI, which is about connecting to databases. In professional environments, the most critical data lives in SQL servers, Azure, SQL, MySQL, Postgres Server, Oracle, Snowflake, Databricks, Azure Synapse, data warehouses, or lakehouses. Basically, anything which is a database online or on a data server. Power BI connects seamlessly to all of them. SQL Server connectivity steps are as follows. Same, you need to go to Home, select the Get Data option, and select SQL Server or any of the database where your data is existing. Enter the server name, database name, which is completely optional. Choose the Import Query option, Dual Mode, provide credentials, select the tables that you need on your Power BI window, and then, based on your requirement, either transform the data or load. SQL Server is extremely common for storing sales transactions, customer data payment, information, inventory, employees, employee data, ERP data, CRM data, and a lot more. Why it matters is the next question. Database connections allow you to integrate large, structured, professionally maintained datasets. This gives your report enterprise credibility, similar to how a researcher gains credibility by referencing authoritative resources. Now, Azure Cloud Database Connections, Azure SQL Database, fully cloud-hosted SQL database used by modern businesses for scalability and low maintenance. Azure Synapse Analytics. So Azure Synapse Analytics is an enterprise warehouse for big data and analytics. Azure Databricks for AI and ML and large-scale data processing. Azure Data Lake for massive unstructured and semi-structured data storage, business-relevant insight, cloud database support, real-time dashboards, large data volumes, global reporting, multi-department analytics, and a lot more. Companies adopting cloud architectures rely heavily on Power BI to interpret their cloud data ecosystem. Now we enter the section 6. Data load versus data import versus data query. This is one of the most important concepts in Power BI. How to load your data determines the performance of your report, the freshness of your insights, size of your dataset, the speed of processing. So now let's break down the 3 modes the Power BI offers. The first one, import mode, and how it works. Data is copied from the source into Power BI's internal storage, and it is through VertiPack engine. Fast performance, best for dashboards that don't require second by second updates. Now, where is this ideal? It is ideal for small to medium datasets, analytics dashboards, visualizations, monthly or weekly reporting, and it deals with Excel plus CSV plus SQL tables. Now let's also discuss the benefits. It is extremely fast in queries, full Power BI functionality, compression can be done up to 10 to 20 times, and there are also some limitations. Let's go through them. Data size is limited, not suitable for real-time systems, and let's also discuss some of the real-time examples. So one of them is monthly sales report where data refreshes every morning. Now the second type is direct query mode. Now let's discuss how it works. Data stays in a database. Power BI queries the source in real time. No data is stored in the Power BI itself. It is in the database. Now where it is ideal? It is ideal for real-time dashboards, very large databases, enterprise level systems like SAP, Oracle, or Synapse. Now let's also discuss the benefits. Always fresh data, no dataset size limitations, and apart from these, we have some disadvantages. Let's go through them. It is slower in performance, many DAX features are unavailable, load depends entirely on the database, and visuals refresh very slower. Let's also discuss one of the real world examples. A logistic company monitoring real-time vehicle movement is a perfect example for this one. Now comes the third one, which is about the live connection. It is mainly used with analysis services, Azure Analysis Services, Power BI dashboards, Microsoft Fabric semantic models, and a lot more. It behaves similar to direct query but optimized for enterprise models. Now, what's the key decision rule here? Choose import mode unless you need real-time insights, your dataset is too large to import, your company mandates live connection for governance. This decision is strategic choice similar to selecting the right learning strategy. Which is like memorizing versus understanding versus applying. Each has strengths and constraints, and choosing the right method enhances efficiency. And with that, we have come to the end of Module 3 and we transition into the Module 4. So the Module 4, which is all about data transformation with Power Query Editor. So welcome to Module 4 of our Power BI course. In this module, we will explore Power BI's Power Query Editor and one of the most essential tools in Power BI for preparing and transforming data. Think of Power Query as the foundation of your analytics workflow. Without a strong foundation, even the best dashboards can give misleading insights. Cleaning and transforming data ensures that reports are accurate, reliable, and actionable. In this real world, most datasets are messy. They contain nulls, errors, duplicate rows, inconsistent formats, or unnecessary columns. Power Query gives you the tools to handle all of these in one go. Power Query helps you with repeatable automated way where you can once define these steps and Power Query will take care of them in the flow. Now, the section 1, Introduction to Power Query Interface. When you open Power Query, you will see a structured workspace designed to make transformation easy and intuitive. At the top, we have the ribbon. It contains tabs like Home, Transform, Add Column, and View. Each tab provides key commands for shaping your data, and on the left you see the Queries pane, which lists all the tables and queries in your project. You can select Rename or Reference queries from here. The center of the screen shows the Data Preview grid, where you can see your data table and apply transformations. On the right side is the Applied Steps pane, where every change you make to your data is recorded as a step, and this step-by-step process is extremely powerful. It allows you to track, edit, or remove any transformation without starting over. Finally, at the top, there's a formula bar where the displays Finally, at the top, there is a formula bar which displays the underlying M code for each transformation. Even if you never write the M code manually, understanding that it exists helps you appreciate how Power Query automates and records your steps. Now comes the section 2, cleaning the data, removing nulls and handling errors. Data cleaning is often the most time-consuming part of any analytics project, but it is also most critical. Let's start by null values. Null values appear when the information is missing in a dataset. For example, a customer record might not have an email address or a sales transaction, maybe a missing discount, or a lot more. In Power Query, you can choose to remove these null values. Replacing nulls is usually better than removing them completely, especially when the missing value has a business meaning. For example, a null discount might simply mean the product was sold for a full price. You can replace nulls with zero, average values, or even label them as unknown depending on the context. Next, we have handling errors. Errors occur when data is incorrectly formatted, calculations fail, or conversions don't work as expected. Power Query lets you remove errors, replace them, or investigate them. For instance, if 50 rows of date values fail to convert, you can check why. Perhaps the format was inconsistent or the data was entered incorrectly. Lastly, let's talk about the duplicates. Duplicates can inflate metrics and distort insights. Power Query allows you to remove duplicates either across entire rows or selected columns. But be careful. Sometimes repeated entries are legitimate, such as multiple orders from the same name or the same customer. Always analyze before removing any duplicates. Now, with that, we enter the section number 3, which is about the column transformations. Once your data is clean, the next step is about transforming columns to prepare them for analysis. Changing data types, every column has a data type, such as text, number, date, or boolean. The correct data type is critical because calculations and visuals rely on them. For example, if your sales column is text instead of a number, sums and average will fail. Splitting columns. Splitting columns is useful when a single column contains multiple pieces of information. For example, a full name. A full name column can be split into first name and last name. Similarly, a product code like PRD123USA, which can be split into category, ID, and country. Extracting values from Power BI allows you to extract specific parts of the column. First characters, last characters, ranges, or patterns. You can also extract years from dates, domains from emails, or UTM parameters from marketing URLs, conditional columns, or UTM parameters from marketing URLs. Next is conditional columns. Conditional columns let you create logic directly in Power BI query. For example, if revenue is greater than 50,000, mark the row as high value customer. This ensures that business logic is applied before the data reaches your visuals. Next is group by. Grouping helps you summarize granular data. You can calculate total sales by region, average orders value by product, or counts by the customer. This is particularly useful when preparing large datasets or dashboards. Now we enter the section 4, merging queries. Merging queries in Power BI is equivalent of SQL joins. You can combine multiple tables to enrich your dataset. For example, you might have a sales table and a customer table. By merging them on customer ID, you can add customer names, regions, and other attributes to the sales table. Types of joins include left join, right join, inner join, full outer join, and anti-joins. Merging is essential in real-world analytics because data often resides in different systems. By merging correctly, you can create a unified dataset that drives reliable insights. Now we enter section number 5, pivot columns. Pivoting converts row values into column headers. For example, if you have monthly sales in rows, pivoting months turns them into separate columns for easy comparison. Pivoting is often used when creating matrix-style dashboards. Unpivot columns. Unpivoting does the opposite. It converts columns into rows. This is particularly useful when you receive wide format data such as budgets or survey results because Power BI works best with long format tables. Now let's move into advanced splitting. Beyond simple splits, you can handle complex cases. Splitting product codes into multiple dimensions, extracting UTM parameters from URLs for marketing analysis, separating full names or addressing into components. Mastering pivot, unpivot, and splitting gives you full control over how data is structured, ensuring that your models are both clean and analysis ready. Now, the conclusion to the Module 4. To summarize Module 4, Power Query Editor is the backbone of Power BI. It allows you to clean, transform, and reshape the data in a repeatable and efficient way. By mastering these skills, cleaning nulls and errors, transforming columns, merging queries, and pivoting and unpivoting data, you ensure that the data feeding your reports is accurate, reliable, and structured for analysis. In the next section of this module, we will dive deeper into demonstration of data connections on Power Query, where we will use these clean and transformed datasets to build relationships, create measures, and enable advanced analytics. So now we are in the part B of Power Query. So part B of Power Query is all about importing data from multiple variety of sources. So your data can be in a cloud storage, in a database, in an Excel file, in some folders, in PDF, in WebPreet, which can be analyzed is your data for your Power Query. That's the source for you. So Power Query helps you with that. It can extract the data from any source you get to it, and it will make the data ready for exploration, insights, and analytics. Now we will be exploring that particular tool in our session for today. So let's go with the dataset that we are dealing with today. So in this particular demonstration, we will be using Excel files, folders, and we'll also using web scraping for our data set. And these are the wide variety of datasets that we will be dealing with today. And we'll also be performing some merging and joining operations as well. So let's get started with the simple dataset for now for learning purposes. So this is our employee data set. So we have the first column, which is name column. The second column is the gender column, the department column, salary location, and the start date as well. So in the first column, we have unique names, and in the second column, we have gender. So this particular data set has some elements missing, right? You can see in the gender column, we have some blank cells as well. And in the department column, we have a lot of options: business development, training, engineering, research and development, product management, support, human resources, etc. But along with that, we also have few departments named as nulls, right? So remember this. In a few situations, you might recruit an employee, right? Here you can see this particular employee was recruited in the year of 2025. So maybe he's on bench period. So maybe he's an intern, or maybe the company just hired him based on his, or I mean, the company's requirement. He might be moved into a dedicated team. So there was a little misunderstanding or something going on in process to dedicatedly appoint that employee to a specific domain, right? And apart from that, if you see the salary section, you also tend to see some blank columns or blank rows or blank cells, right? So no blank columns, it's blank rows actually. So you can see another blank here. So these are a few inconsistencies that we have in our data set. And apart from that, if you see the location details, in the first row, you can see 3 Redmond Bay, Bellevue, and Washington, USA, right? So the problem is, let's say you wanted to extract the country, but you might feel we have this particular data in a comma separated, format. So you can quickly go to data validation and separate the columns based on delimiter. But is it the same? No. If you expand this particular cell, you can see this particular data is entered in a new line, but not comma separated. So that's the problem, right? And how would you apply split or delimiter based data validation here? That's difficult. But Power Query has a good tool for yourself. So the thing is, you can explain Power BI what your intention is. Like, let's say you just extracted the first or last few um, words of your particular location. Let's say, since this is USA, I want to extract the last 3 letters in this particular location. You can extract it. But down the line, if you have different countries, maybe Australia, then what it does is it will separate only the last 3 letters of Australia, and the rest will be left out. So this is not the way you want to work with your data set, right? So for this, you might have to work in detail with your formula. You might have to struggle writing the formulas for that, but don't worry. If you're not so strong with the formulas, and if you're facing tough time to recognize the text character based functions, you can just write few cells. It's like flash fill in Excel. You can explain your intent to your Power Query tool, and it will understand what you're trying to extract. And based on that, it will extract the data for you. As simple as that. We will be also working on that. And lastly, we have the start date column. So this is the rough overview of our dataset. Now, let's go to Power Query. So for that, you might have to go to a new blank workbook. So we can continue with Excel here, but you can also continue with Power BI as well. Why Excel? Because the Power Query interface will be completely same compared to Excel as well as Power BI. So both are Microsoft products. So on Power BI as well as Excel, you will have the same interface for Power Query. So for learning purposes, let's also explore Power BI as well. Now let's create a blank report. And here you can see the get data option, same like Excel. So if you go to data, here you have the get data option, and you have a wide variety of sources you can choose from. Excel, you can choose from text or CSV, you can choose from XML, you can choose from JSON, you can choose from .pdf, or you can also provide a folder. So we'll also deal with the folder option. So in the future use case, we will be creating a sales dashboard where we will be having year on year data set. So we'll be having a data set from 2020, 2021, 2, 3, 4, 5, and 6. So you will have a wide variety of sales files, and that particular folder will be saving all these files. Let's say tomorrow you'll have 2026 data or 2027 data on future data sets. What you can do is just drag and drop the file in that particular folder, and Power Query and Power BI Desktop will automatically understand new data has been added to the file, and it will run all the steps we have made Power BI or Power Query to learn and get the data ready for analytics. So you'll also be exploring that. And apart from files, you also have a database. So here you can get connected to SQL Server database, Microsoft Access database, analysis services, SQL Server analysis. And apart from that, you have Azure. So we also have Azure, as we discussed in the part 1 of this particular module, the 4th module. We also can connect to Azure as well as Azure Data Explorer. So you need to have some credentials for that, but don't worry. So for the basic understanding purposes, we'll be dealing with the website data, we'll be web scraping the data, we'll be loading data from files and Excel documents, etc. And you also get some other sources as well. You can, as we discussed, the web and ODBC, OL, EDB from picture. You can also post a single picture just like AI does today. You just post a picture, it will build websites for you, it will extract the data for you. So the same feature is also integrated into Microsoft Power Query as well. You can combine queries where you can append the data or merge the data. Similar to SQL join operations, you can also Power Query editor, you can launch it, and a few more query options. Let's say you wanted to edit a particular step. Okay, when we dive into the Power Query editor, you will see the steps on the right hand side and the queries on the left hand side. So based on that, if you wanted to edit a particular step, you can also do that. So this was the option from Excel. Apart from this, if you go back to your Power BI window, you can see a similar interface. You can go to get data, and you can also go to more here, and you have you have file, a database, Microsoft Fabric. So remember Microsoft Fabric, it's the new integration into Microsoft Power BI for data. So it's like a data lake, and you have Power Platform, Azure Online Services, others, right? So I think you already know the detailed differentiation between a data warehouse and a data lake. So roughly, a data lake is where you don't have organized rows and columns. It's like you'll have a wide variety of resources. You have images, multimedia, and all of those, and you can choose. This particular data lakes are very essential for machine learning purposes. You can choose what type of data you want to deal with, and you can directly access it. You don't have to modify and forcefully store the data in dedicated columns and rows. So those are data lakes. You can also explore that further in the data lakes tutorial on our channel. So apart from this, these are the data sources. You can also connect to a SQL Server, Access database, and a lot more. So let's go back to the basics. So we are on the new Excel spreadsheet here. Now all we need to do is quickly import the data from the Excel file. So I'll go with the Excel dataset, and the first dataset that we will be exploring is Excel workbook. So I'll be selecting the Excel workbook here. Now we need to navigate. Let's give it a little time to open the browser window. So my data is in downloads. So Power Query examples, datasets, and here is the employee dataset that we were discussing previously. So click on import, and it will take a little bit of time to load the data. It's establishing a connection. Now, any moment you can see a Power Query window. So there you go. So here you have just one file that's showing you the preview directly. In some situations where you have multiple files, just like we discussed before, sales data from 2020, 1, 2, 3, 4, 5, 6, and beyond. In those scenarios, you might just have one file available for you on the preview. But in case if you wanted to see all the files, you have a little option here, the checkbox, which says select multiple items. So if you just click on it, it'll give you all the data sets available in that particular file. And now I just have one, so you can just click on that particular data and you have a quick review. So when you click on the dataset here, when you uncheck this, you cannot see the load options, right? But if you click on this, you can unlock or activate the load, transform data, and cancel options. So what these does is, let's say you're completely happy with the data you have. You know that your particular data set is completely clean and ready for analytics. What you can do is you can directly load the data set onto your analytics platform. For now, it is Power BI, right? You can directly load the data into Power BI and get started with your analytics like building charts, graphs, even dashboards, interactivity. You can add filters, slices, etc. But in case your data is completely raw and you need to manually filter it, then you need to go to the transform data option. So now, since we know that our data set needs some cleaning, we will click on the option that says transform the data. So click on transform data, and soon you have a quick Power Query window. So as we discussed, the right hand side will be the steps, applied steps will be recorded, and on the left hand side, the queries that we are applying on our data set. So in case if you wanted to edit any query, you can quickly come to this section and choose to edit the options. And on the right hand side, we can see already Power Query window has took the liberty to make some changes to your dataset, right? So the first one is it chose the source, then it navigated the source, and it promoted the headers. So what has promoted the headers? If you go back to the dataset, here you can see the first row is name, gender, department, salary, location, and start date. So Power BI's Power Query or Excel's Power Query was intelligent enough to understand that the first row entry is the metadata or column header, or you can call it the name of the column in most layman's terms. So it understood that this is the row header, so I need to push this as the column header or the row header, and it took the liberty to do that. And apart from that, it also took the liberty to change the data type. So if you come back to the original data set, you can see it understood the format. So we have the dollar symbol, right? It automatically understood that this particular number should be a whole number because this is a salary number. And the location details are automatically set to character. You can see the ABC logo here, and you can see the 1.2 symbol, which means the whole number with decimal points. And you can also see the ABC character data type for department, gender, and name, right? So these are the few steps which Power BI took the liberty to help with us. And now let's go with the first requirement that we were talking about. In the original dataset, we had some errors, right? So we had some null entries. So we need to change that. So here you have the option. But before we begin with any operations, let's have a quick overview on the ribbons we have. So here you have the close and load option. This is the most important one. Whenever you apply all the steps you need and you're happy with the dataset transformations, then you come here and choose the option to close and load. What this basically does is it saves all the transformations that you apply to your dataset and saves them, and then loads the data to your Power BI platform or any platform you choose. So you have two options here: load, like close and load directly, or if you choose a different one, let's say you wanted to load to the Power BI platform, you can choose that. So the default close and load will load this particular data to the Excel because we're working currently on Excel. So that's how it works. And next comes the refresh preview option. Now, what is refresh preview option? As we discussed, in a file, there could be chances that you might add new data eventually. So whenever new data is added eventually, you just need to click on the refresh preview and Power BI will automatically understand there is new entry for the data, and what it does is magical. It takes its navigation directly to the applied steps. So here it changed or applied a few steps here. So it again changes the data type, it changes the promoted header step. It will remove the first row and it will automatically think this is the column header and it will promote it to the column header. And apart from that, if we are going to perform some operations here, like adding others to the gender column and changing the null value to engineering or any dedicated department, and then in salary section, if you remove the null values and then if you separate the country from this particular location column, it will record all those steps and it will automatically implement these new steps. I mean, these particular steps onto the new data. And you don't have to do this repeatedly. The most important aspect of using Power Query is automation. So the entire part of your data transformation will be automated. And whenever you load new data, you don't have to, worry about anything. Power Query will handle all the transformations and gets your data ready for your next step, which is data visualization. That's the magical part of Power Query. And apart from that, you have properties, manage, and choose columns. If you go to choose columns, let's say I just want the name and department here. Now, what I can do is I can choose the columns and then it will give me a window. So let me go ahead with that. So it will give me a window where I have the liberty to choose whatever columns I want. Let's say I want to go with name and department. It will give me only name and department and any other things which we want to go ahead with. So that's the best one. And remove columns. So here you can see promoted to headers, right? But in case if let's imagine that our data set had some misconceptions, like the first column or the first row was completely empty. In those scenarios, Power Query will consider that empty row or an empty column as a null value. And we don't want that null value. In those scenarios, you can choose to remove that particular column or that particular row completely. And you can see a similar option here, keep rows and remove rows. And the similar options like Excel, where you can sort the data in increasing order or decreasing order. And remember the column splitting that we spoke about, the data validation option that we used to have in regular Excel, where it identifies the delimiter and splits the data into columns, right? So that option is here, and you can also go ahead with group by options and use first row as headers. So this was the step I was talking about. Power Query automatically did that for you. You don't have to worry about it. And replace values, we'll be using this replace values. So the first place where we have to use these is replace the null values with a dedicated value you want to add in. And apart from that, you have merge queries option, append queries option, and manage parameters, data settings, and a few others. And here you have the transformation option where you can transpose the data, reverse the rows, count the number of rows, use first row headers. You can fill some data sets, and you have a pivot and unpivot columns option here. We'll also be exploring that. And you have extract the data, parse the data, statistics, standard deviation, and scientific columns. And you also have a date option here because we have date column here, right? And you can also choose to add some customized columns as well. Remember the column I told about where you don't have to worry about the formula. You just have to explain Power Query what is your intention and it will extract the data for you. That's the one here. So you can choose to have a custom column, or you can also choose this particular one. Our requirement is column from example. So you will add a new column. You will provide few examples from the location. You'll just write USA, and in the next one you'll write the next country, which is New Zealand, NZ, and so on. So based on your requirements, based on what you're applying, it will think like you. It will understand your thought process, and based on that, it will help you extract the countries. That's magical, right? So no worry, we'll also go through that in a moment. And the last one is conditional column, duplicate column, all those. And the last one is the view one here. So you have formula bar. Okay, remember the formula bar. For now, you have this particular formula bar. Let me highlight that, right? So I've done this a few times, so I have this particular column option available. So in few scenarios, if you're new to Power Query, in very rare scenarios, the formula bar is not visible. In such scenarios, what you can do is you can go back to the view option and enable the formula bar so that you can see this particular formula bar and see what is the operation being run on your particular data set. So this was a quick overview of your ribbons on Power Query window. Now let's go back to the home ribbon, and here the first operation, department. So we will be replacing the null values with some dedicated value that you are interested in adding, right? So yeah, I think we missed out the second column. This was the gender column. We need to work on this first. So you just need to select the column, and there are multiple ways to do this. You can go to the add column or transform option and choose the replace values from here, or simply right click and then you have the option which says replace values, right? So for now, I think we have null, the empty value. So there are two meanings for it. If it is lowercase null, it means the columns or the that particular cell is blank. But in case if it is capital null, then it means it is character data type and it was dedicatedly written as null, right? So you need to understand the basic difference between nulls. So this is the null value we're dealing with. And in place of any blank cell where the value is null, let's write it as others. So others will be the gender in place of a null value, and this will be your first transformation step. And take a look on the right hand side. So whenever I click OK, a new step will be registered. So that was the replaced value, and a new step has been successfully registered. So if we scroll down the data, we should be finding some others. So here you can see the others entry, and now the first column, or in our case the first transformation is successful. Now comes the department part. Similarly, you can go ahead with the replace values option here, and in this particular option we need to write down uppercase null. And let's imagine any new employee, let's say our requirement is in engineering, so any new employee which has been recruited will be provided to engineering department. So I'll write it as engineering, or it could be product management based on the requirement, right? And I will click OK, and the next replace value function is also successfully done. And this is simple, right? This is our imagination. But in case if it is a little complicated, let's say any employee that was recruited in the month of March 2025 should be for marketing, and any employee which was recruited in the month of May in 2024 should be for business development, right? You can also do that. You have the operation called add column based on a condition, and you can provide the conditional column and then move these employees to a dedicated team. And that's a lesson for the next session. Now we have another column, so let's quickly go ahead with that. In here, you have null values as well. So instead of just replacing these null values with some random data and making it complex, since it automatically took it to a float value, here you can see the fourth step, right? So let's not do that complication, but instead what you can do is just quickly apply a filter and unselect null, so that all the employee details which are no longer working with this particular organization are erased. Not erased totally, just filtered out basically. So now this was the thing. Apart from that, if you wanted to, yeah, the next operation is about extracting the country. So now the fun part. So go to add column, and here column from examples. Now here it will ask you two options, from all columns, and the second one from selection. So we want to go with the selected column. So we'll go with the second option from selection. Now it's your duty to train Microsoft Power BI your thought process, the way you're thinking. So if I go into this particular cell and I write USA, it understands, okay, he's trying to extract the country USA. Automatically, wherever it finds USA, it has extracted USA. It's still in process. Now I come to the row number 3 and I'll write NZ for New Zealand. It understood NZ, and here you can see the highlighted row number 6. It has written some ELS, but ELS is not my expectation. So what I'll do is I'll quickly rewrite this as USA. It might take a few iterations, but not more than 6 or 7. It should, like, normally 2 to 3 iterations will make Power Query understand your requirement. So you can just eyeball everything, and once you're happy, I think we have about 1,000 entries here. So 1,000 entries are good enough, and all the entries have successfully extracted the country. And you can just click on OK, and your new column has been successfully added. You can also rename this particular column as country PRY. There you go. So your new country is successfully added. And in case if you don't want this, you can eliminate it. But in case if you want to continue having this address, you can keep it. So for me, I don't want it right now. I'll feel free to eliminate it. And you have a good amount of data. And in case if you wanted to go ahead with, the separated column for year, you can also do that. So you just need to go the first column, which is start date column. You can select the column, and here you have the date option. So what you can do is year. Select the year, and a new column which is dedicated for year has been successfully added for you. So your data is almost ready for analysis. So what you can do here is you can just go back to the home option, and here you can choose to close and load the data. So there you go. You have a completely filtered and purified data ready for analysis. In the same way, your data will be loaded to Power BI as well, and you can go ahead with visualizations part. So on the flow, in these next upcoming sections, we will also go to it, where we will load the data directly to Power BI, and we will start with explorations as well. And we will also create a wide variety of charts, column charts, bar graphs, pie charts, donut charts, and a lot of options which are available. And apart from that, we will also create a highly interactive dashboard. As discussed before, we will be having sales data sets, and we will be working on the first current 5 years of data sets. And then we will also add a new data set of the upcoming year or the current year, and then we will just refresh the dashboard, and automatically it recognizes the changes, and it will load the data, and you'll have a fresh data set or dashboard which is completely interactive. So there are a lot of things which can be done, and here on the right hand side you can see the query options. If you click on that, you can see you will be back on the Power Query window, and you can see all the steps that you have applied. And in case if you want to change anything or if you want to remove anything, you can feel free to just click on that cross icon there, and it will remove that. So that's how it works. Now you can close this particular query settings and go back to the dataset. And in case if you have any connections with other datasets as well, you can establish that connection with your datasets, and it will be good to go. And you can also include this particular data for creating a pivot table as well, which looks something like this. So let's select all the data, which is completely clean and ready for execution. You can go into the option which says pivot table, and here you can choose a new sheet. This is how it looks like. So you can choose to go with a new sheet, and you have a pivot panel ready for you. So what you can do is maybe drag and drop department into rows, and then you can also include the salary, and now you have how much salary are you paying to each department. And apart from that, if you wanted some a little more detail, you can also drag and drop the name row to values. So you have the count of employees in each department. So you can see product management has almost highest kind of number of employees, and you can also choose to kind of sort this just like you do in regular Excel. You can choose this particular table, and then you can sort based on increasing or decreasing order as provided here. And apart from that, you can also choose to add a date or year here. So year to columns. So you have a side-by-side approach of 2024 data and 2025 data, and all the details of the employees and the salaries, everything, right? So this was the first approach, and we can name this as pivot table, right? So this was the first approach of loading data from an Excel file. Now let's go with the second approach, where we wanted to get the data from a web page. So I'll close this Excel file. You can choose to save, and let's also save the previous one. This can also be saved as a reference file. I think I saved it previously already. Yeah, there you go. Now we have opened one of the web pages, and I think Power BI is also open. Not a problem. You can close this. Don't save anything. Yeah. So we can choose any of the open source datasets. So before you go ahead with web scraping, understand this fundamental rule. So there are many websites out there. It can be based on cryptocurrency websites. You can also know where the current value of a Bitcoin or any crypto coin, right? So such websites, they have some security concerns. That particular data is not available for open source, right? So most of the times when it comes to data analytics or business analytics perspective, web scraping is very rarely done. But from organizational level, web scraping can have a little bit of room for it. So there will be websites which have a dedicated log for them, so they don't open source their data for public users. And there are some websites which are open for everyone. So based on your choice or based on your requirement, you can go ahead with the web scraping option. So in my case, I'd like to go with some open source learning pages like Wikipedia, something like that. So I'll type Wikipedia, American population or Indian population demographics, such datasets. So let's go with this one. United States territories by population, or the first one, demographics of United States, right? So here we have some data tables. So here we have median males, females, total population, country, and yeah, this is year-wise data. And here we have rank, name, side-by-side approach. Yeah, this one is also good. Year-wise, average population, live births, deaths, and all those. So you can choose any of the web page that you feel comfortable to work with, or based on the requirement, if if you receive any of the dedicated link, you can go ahead with that. So the approach is simple. So I think this particular data looks good. So here we have, you know, uh, state and then census population and largest cities, etc. So I'll go ahead with this particular web page. So I'll copy the URL. This is the first step, and go to Excel. Once you reach to Excel, you can create a new workbook, or you can choose to go with the reference workbook as well that we created previously. I chose to go with the new workbook, and here we go to the data option. So it is completely similar in Power BI as well. So we are doing this for learning purposes on Excel, and once we're comfortable, we can go to Power BI. So since Power Query has the same interface on both Excel and Power BI, it's comfortable to go with Excel as well. So I think I closed Power BI. Yeah, so blank. And here you have the get data option. So here you can choose the option which says web. You just need to simply, okay, cancel. You just need to simply drop the URL and it will load the dataset for you. This is the one. You can simply place the URL and click on OK, and it will open the Power Query window for you. Similarly, while that happens, you can choose the get data option, and here you can provide from database, Azure, others. Here you have the web option from web. So if you are applying this for the first time, you might get a few options where you have to choose basic or advanced or based on the requirements. I've done this a couple of times. So it will just directly take the request and load the data for me from Power BI or Power Query window. So this is the one I was talking about. So access web content. So here is it asking for anonymous, Windows, or basic. So you can choose anything based on your requirement. If it is basic, you need to provide some credentials. If it is Windows, and you need to provide the current credentials of your Microsoft account, I would like to go with anonymous for learning purposes and connect. And slowly the Power Query will be starting for you. So meanwhile, let's also check on the Power BI platform. So here you have the preview. So it's completely similar on Excel as well as Microsoft Power BI. So you can just go to the view option. So this is the first table. So here we have columns and rows. So here you can see some values. So if you go back to the dataset on web page, here you can see some aggregations of, I mean, not aggregations, combination of the first two rows. So the first two rows were combined and named as state or territory. In the same way, here you can see the preview. Null value is placed in the first entry, right? And some naming conventions are gone wrong based on the web engine here. So here you can see some links, right? So some links are attached to this particular table. So what Power Query did is it considered this as a data entry, and this particular elements are also visible on the Power Query window. So you have the complete authority, and you have the complete options to rename the columns and eliminate the first row, right? You can do some changes on that. So let me close this here and go back to Excel. Let's see if that got loaded. Yeah. So here you have the select multiple items. So you can choose to select multiple tables you want to go ahead with, or if you want to go ahead with only one, like we discussed. So we can also go ahead with only one table. So you can quickly have a preview. So if this is the one you're looking for, since we had a lot of tables in the original web page, right? You have a table over here. You have furthermore, if you scroll down, you have one other table here, another population states table here, right? A lot of tables. So you can go through all the tables, review, and select the one which you're looking for. So this is the one I'm looking for. So what I'll do is go to the transform option, and now it will open me the query window. So just like we had before, left hand side will be for queries and right hand side will be for applied steps. And similarly, it shows the liberty to do some changes for us. It promoted headers, changed data types. So I want to take the control for myself. So I'll remove the change data types and also promoted headers. So far, so good. Not a big problem with the headers, but we always have the option of renaming, right? So now let's rename this particular column header as census population _1 and this one as well. So we can go with rename. So this could be census population _2. Largest cities is good enough. Largest cities 2 is good enough. House seats B. Okay, why don't we name it as A? Or I think since house seats is good. Now this will be B by default. Let me remove this. There you go. You can also vote. So rename votes to population percent votes in 2020. And this can also be renamed. So this is simple, but we are doing it for multiple times so that you have a quick understanding. You have a grasp of how to continue when you're on your own. So here you have percentage of US in 2020, percentage of EC in 2020. And now so far so good. Now, remember the option that we were discussing about removing rows and columns? So here you can see some irregularities in the first column or first row, right? So here you can see largest cities. Okay, I think this can be named as city name, right? So rename it as city name and city population so that it is a lot more easy to understand, right? And seats could be good. Seats percentage null, right? So far so good. So what you can do is choose the remove rows option and it will ask you the options top rows and bottom rows. Based on your requirement you can go ahead with that. So I'll go with the top rows, and what I will do is yeah, it will ask me how many number of top rows you want to delete. Let's say I have problem with the top 2 or 3 rows. I can directly specify the number as 2 or 3, but now I have only problem with the first row, so I'll provide the number as 1, and automatically the first row will be eliminated. Again, when dealing with such web extracted data or web scraped data, you need to be very careful about the steps you're applying, right? Now, for this scenario, we have changed some column names and all of those things, but tomorrow the columns might be rearranged. For example, here you can see state and territory. The next one is census populations, right? Instead of state and territory, you might have city name, right? The columns might be swapped, or maybe for the next time, the hyperlinking on the data table may not be done, right? And also there is a good chance where the dates, right, July 2024, April 2020, city names, city population, there might be slight changes to these, right? So this type of operations, when you're dealing with web scraping, you need to be at most careful with what are the steps you're applying. Mostly these are not preferred in real time in business perspective or data analytics perspective, but on the organizational level, very rarely this will be done, but it can be a long time consuming process. but make sure that you're applying all the steps that you are considering. Now, if I see all the data set ready for me. Now, what I want to do is I'd like to select few columns and run my analytics. So we have the choose columns option over here. So I'd like to choose the columns of city name, city population, and maybe population percentile of vote, and OK. So out of 3 million people, only 720 or 732,000 people chose to vote, or maybe some miscalculations in the voting terms, right? So let's go with the analysis part of it. I'd like to go with the population city. And if you're comfortable with the data set that you have, you can choose to close and load. There you go. So the queries, connections, extremely similar to what the process we made previously. And you have the option of forecasting, right? So in the current year, this is the population and what could be the future population. You can add a quick, forecast data for your data set. And apart from this, you can select this particular data set and you can choose to go ahead to Power Pivot, and here you can insert a pivot chart. So you can go ahead with any of the charts available, and you can have a demograph of all the charts. And that was part 2 of loading the datasets. You can quickly choose to save this file, and let me save it as reference 2. And now will be our next part. Now, so far we are done with the web import of data. Now let's go with another part. Cancel. We don't want to close Power BI yet. So the other part will be where we will be processing some appending and merging operations, which are completely similar to SQL joins. So this has been saved, so I'll close this, save and close. So I think we have a lot of states there. That's the reason bar chart was not showing any data. Not a big deal. So just for learning purposes of web scraping, we did that. So now I'll start a new workbook altogether for the third reference part. So the third part, initially we did Excel, then we did web scraping. Now we will be doing the appending and merging operations. So this is the fresh workbook. So again, we need to go back to the data option. So we will be loading the data from file, and again, Excel workbook. So this workbook has multiple files in it. So that's the overall approach where we will be performing the appending operations. So we'll be in datasets, and this is the one, students and courses, right? We will load it. It might take a little time, but not to worry. Yes, there you go. So you remember the select multiple option we discussed before? That's the one. So we have courses, so we have years as well. So now we will be transforming the data. So now we are on the Power BI's or Power Queries window. Now, so this particular table is the courses table. So we have some random courses here, the respective teachers, lesson type is a practical theory or internship. Then we also have a credit score like 1, 2, 3, so 4, so on. And we also have assessment type. Which type of assessment did they face? Was it a quiz type assessment, continuous assessment, return or project work, or was it oral assessment, right? Just something like that. And then we have year 11 and year 12. So these are the students in year 11 and these are the students in year 2. So what is the main purpose of this particular attempt? So in this particular attempt, as you can see, we have students, their gender, their course, and we also have courses. Now I want to know which particular student has taken what course and who was the dedicated professor or teacher. and what type of lesson are they receiving. Is it practical, theory, internship, anything like that? And then what are their scores when they write an exam or when they have a oral exam? Then what is the number of marks that they have achieved, in what format? I want to know that. But here all I can find is student name, gender, and course. Their marks or the grades that they have received, what type of lesson did they receive, or what type of assessment did they face, who was the teacher. These details are not available in any of these tables. And again, we have two different tables here. One is year 11, another is year 12. Now, how do we do that? That's the question, right? That's where the home ribbon has two options: merge and append functions come into the picture. So automatically it changed some data types. So here you can see only applied steps, and here as well it has changed a few things. And when it comes to courses, so credits, it took the changed data type, it automatically made it to a whole number. That's great. Now we need to combine both year 11 and 12. So for that, I'll choose year 11 and go to merge queries. And after that, I think we were supposed to go with append queries, not merge. Merge is the next step. So two tables. So you can choose two tables or more than two as well, three or more. For now we have just two, so we'll go with the two tables option, which is default one. So here you can see we have year 11 as current. So that means we are currently in year 11 table. So I want to connect or append the data of year 11 with year 12. Then press OK. And now you have all the data of year 11 and year 12. But there is a small bottleneck. How do I identify which student belongs to which year? Okay, and also I think we missed out on the column headers. So in such scenarios can be reverted, not a big deal. So what you need to do is just click on the cross sign here to remove that function. And now what we will do is we will do some changes. So select the dataset and then click this particular option which says use first row as headers. So this is the fundamental thing which you need to remember. Always check the column headers. Once you're satisfied with the column headers, then you can go ahead with the rest of the process. Now this was step one. Now what I want to do is add a dedicated column which says this particular column is data related to year 2012. So I'll add a custom column. I'll name this as year, and within I want to add a text based input here. So within the double quotes, I'll add year 12 and press OK. So this is automatically, okay, we need to change the data type. You can change type to decimal, whole number, percentage, text. I want to keep it as text. So again, let's try that again. Okay, there you go. Now, similar approach should be followed in this particular table as well. So we will go to a custom column. So the custom column will be named as year, and within the double quotes, we should write year as year 11. So that now we have a quick identifier which student belongs to which year, right? And again, we will change the data type from number to text. There you go. Everything is good to go. Now, if we append, we can identify which student belongs to which year, right? Now we'll go back to home option and here choose the append queries. So append means you are attaching, here you can see the logo, you are attaching one dataset under the other dataset, right? So click that. You have two tables, so go with the default option. But in case if you have multiple, then you can go with three or more tables. So let's go with two here. So we are in current 11. So I want to append the 11 with 12. So click the option table 12 and now you have appended the data. So if you scroll down, you can see until row number 175, we have 11 years, and after that we have year 12, right? So far so good. Now the next task is map these with courses. So for that, we might have to go to the option of merge queries option, right? So here we have course table. So if you go back here, you can see in year 11 and 12, each and every student has a course. So what is course? If you go back to SQL, there if you are merging or joining two tables, you will merge or join them based on one key, and it is called as primary key, right? So you need to have one common column or one common entry on both the tables based on which you can attach or join both tables. So in this particular scenario, course column acts as that one primary key for our merging option, right? So I want to merge year 11. So that's the one where we have all the data sets, right? So you can even rename it. So year 11. Okay, before we do this, it's better we rename this. So I'll rename this as, okay, before we rename, let's make it, make a small confirmation. So we have both, okay. Now, we will rename this as students. Okay, we have students data table and courses data table. So again, go back to courses, use the merge queries option, and the table I want to merge with is students data table, and based on what parameter. So I would like to go with the course parameter or the course column as my primary key. So far so good, you can continue merging, but in case if you want to merge with referencing more than one column, that is also possible. So what you have to do is just hold control key and then click on the column which you want to refer. So here in case of this data set, I'm just randomly selecting gender and teacher. But for our data set, just one column is enough, which is course, and we have selected that successfully. Now, if you scroll a little lower, you have join kind, right? If you open the drop down, you have left out join, which says all from first matching from second. And second one is right, all from second matching from first. Next, we have full outer join, all rows from both the tables. Inner join, only matching rows. Left anti-join is about only the first join. Right anti-join is about only the second one. So the best one to be safe side, right? Even if it is a replica, you can go with full outer join. But the default one chosen by Power Query is left outer join. So I want to go with the default option here. So the selection matches 19 out of 19 rows from the first table, so it's good to go. If there is any error, you could have found it over here. And you also have some option called fuzzy matching options. So if you know what is fuzzy match, you can also proceed with this one over here. But now we don't want to work with fuzzy match. We are good with left join. So you can simply click on OK and the data will be merged. But right now on your screen on Power Query window, what you can see is just table entry. So where are the rest of the entries, right? You don't have to worry here. So all you need to do is go to the top right corner where you can see two arrow marks, one going to the left and one going to the right. So that is kind of an option which says you need to expand this particular column. So if you click on that button, the data will be expanded. Okay, now you have the respective course, the teacher, the lesson they are giving, and what is the credit score or the number of marks they have achieved, what type of assessment did they give, and who is the student and their gender, the course they took, and which year do they belong to. Everything in one shot. Now you can go to the option which says close and load. So click on close and load. So yeah, there you go. It has established connections, queries, and everything in one shot. So now you have three different tables on the right. You can see courses, students, and year, right? So the latest merge option which we did is currently in courses. So click that particular one and you have everything in one shot. So you have the course they have taken, teacher, lesson type, credit score, assessment, and everything. So now let's consider a small use case. Let's say we want to avoid people who have taken practical lesson and have scored more than 2 or 3 credit scores. So for that, how do you do it? So we have a simple filter operation right here. So you just need to click on the filter operation. It is taking a moment. So you can go to home and apply a filter. There you go. Now you can click on the filter, close this. Or I'll do one thing. I'll create a fresh new sheet and then paste it over here. Courses. And here I'll be pasting it. There you go. Now we have a shortcut if you remember. Control Alt H O I. Undo that. Alt H O I. For adjusting the row width, and you have successfully adjusted the row width. Now these are your columns and rows. What you can do is quickly apply a filter and you can segregate your data. So I want to choose practical. The filters are not loading for some reason, but basically that's how you do it, right? So you quickly apply a filter. Okay, let me delete this. For some connections, I think it is unable to load properly. So let's try that again. If the filter is functional, I can see the filter getting loaded, but for some reason it is not staying on the screen. Yeah, so basically what you can do is, let's try to create a new sheet altogether without any data connections. Now we will select all the columns, Alt H O I to adjust the width, apply a filter. I think this should help. Yeah. Yeah, basically what you can do is apply a quick filter, select the filter option, and in which you will select practical. And here you will apply a condition where filter condition will be credit score should be greater than or equal to 3 or 2, right? Based on that, the data will be filtered. So for some reason, I can see the filter, but it is not staying long enough on the screen so that we can apply it. Could be a small technical error, but that's how you basically do it. And that brings us to the end of module 4, where we have learned the basics of Power Query, how to clean the data, how to split into columns, and how to do some basic functionalities like creating an additional column which extracts the data from a logic based on your thought process. And we have also done web scraping. We have considered the Wikipedia open source data sets to do that. And now we have a comfortable understanding of Power Query in both Power BI and in Excel. Both the domains are one and the same. So in the upcoming modules, we will be learning data modeling, DAX calculations, data visualizations, and creating a completely interactive dashboard, which includes slicers, filters, and a lot more. Now let's proceed to the next module. Welcome to the module 5 of this Power BI full course. So module 5 will be about the data modeling in Power BI. So what exactly is data modeling? Imagine you had a store or some online website where you sell some products. So you have shipment data, product data, geographical data, and the sales team data. And apart from that, you might also have calendar data, which is really vital in business analytics. So all the tables are interconnected. So one, which is the shipments table, will be connected to the product table, also to the orders table, sales team table, and the calendar as well, and also to the geographical location, right? It's like the shipment data table is in the middle of all the other tables. It's forming a schema, it's forming a shape, right? So this is data modeling. It might be a little confusing, but don't worry. To have a better clarity, we will go to an Excel dataset so that we have some detailed understanding of what exactly I'm talking about. We'll also deal with the fact tables, dimension tables, relationship between all the tables, and how exactly a data schema is made. And then we will also do some sample visualizations using that particular data model. Now, let's go back to the Excel dataset. So now we are on Excel dataset. So we have shipments table. So we have dimension data and also the calendar. Now, when we come into the shipment table, we have shipment ID, SPID, PID, GID, ship date, amount, the number of items, and order status. So we will look into each of these columns. So the shipment ID is a unique ID for each and every shipment that you made from your website or your inventory. And SPID is the sales team's ID on which this particular sale was made. Who was the person who was the one who is authorizing this particular sale and who took care of the rest of the process. Then we have PID, which is product ID, which product was sold, and the GID is about the geographical ID based on which geographical location was the order placed from or delivered to. Then we have ship date, based on which date was the shipment made, what's the amount and the number of units sold, and what's the status of the order. Is it delivered or is it in transit or is it shipped, right? Some details of that. Now, what are SPID, PID, GID, and ship date? How are they related to shipment data table? That's our next approach. So here we have the dimension data. So in dimension data, we have three tables. The first table is the product table. What products are in our inventory, what category they fall into, what is the cost per unit, and what is the PID. So basically, this particular table, the entire table, has to deal with one item, which is about the products item, right? Now, here you can see the fourth column, which is stated as PID. Now, PID is the primary key which can be used to connect the product table to the shipment table. There is one connection established successfully. Now, let's go into the second table. So, the second table is nothing but the geographical location table. So, here we have a geographical location: India, US, Canada, New Zealand, Australia, and UK, and also the regions: APAC, Americans, APAC, Europe, etc. And here we have the third column, which says GID. Now, this particular GID acts as the primary key which combines the shipment data with the geographical data. So here we have the GID and the shipment ID. So this particular table deals with the geographical location. Now going forward, we have another table which says about the salesperson or the sales team, right? So here we have salesperson who is responsible for the sale, and here the team whom to which they belong to. And third column is the SPID, which combines the shipment data table with the salesperson data table. So this is the SPID we were talking about. Now, apart from these three or four tables, including the fact table, we have another table which is called as the calendar table. So this particular calendar table is nothing different to your regular calendar. It has all the dates, all the months, all the weekdays, and the year table, right? So this is like a calendar. So whenever there is an order or shipment made to that particular date, we will have a registry here. So that is how the calendar table works. Now, here in the shipment data, you have the ship date. So this particular ship date is connected to the calendar table here, right? Now we have all the five tables as per the discussion. Now we enter into the schema, the star schema, which is one of the most popular schema used in the current world of business analytics and data analytics. So here you can see this particular table is the fact table. Why is it called the fact table? Because rest are the dimension tables which deal about the people. So it might be the customer data or it might be the salesperson data. So basically any table which has the details related to customers or the salesperson is one dimension table. And the other table is the product table, which solely deals with the product details. And the other one is the calendar detail. So this particular table wholly deals with only the calendars. And the last one is the location table, which only deals with the location details. So all these people, product, calendar, and people data tables, which uniquely work on one single aspect, are connected to the fact table, which maintains the details of all these tables. Let's say I want to find out, if we go back to shipments table, I want to find out the details on this particular shipment ID, which is 058. So what is in 058? Who was the person who made this sale? what product was sold, to what particular location, and how many orders were placed, what is the status, right? All these details are not available here, but instead of that, we have the SPID. So if I explore the SPID, I will get this particular entry. So this person was responsible for that particular sale and he belongs to this team. And if I go back here, I see P01. So what is the product? If I enter P01, I have this particular product and this particular category, and this was the cost per unit, right? And again, if I go through the GID, this is geographical data. So GID 3 is Canada and the region was Americans, and this is the location where the shipment was sent. And now on board date, it was 28th of June 2024. So here I have that details as well, June 28th, right? And at last we have the total amount paid, the total units sold, and the status was delivered, right? So this is how each and every table is connected to one another, right? So shipment table falls in the center location, and all the rest of the details, which is calendar, people, product, geographical location, all are connected to the shipments table, which is the fact table, and rest of the tables which surround the shipment table are called as the dimension table. Now this might be a little confusing still, but don't worry. Now we will close this particular dataset and head back to Power BI so that we have a comfortable understanding of what exactly I was talking about. So now we are on Power BI. Let's create a blank report and let's load the data from Excel. And here I have the sample sales data. So I'll open this. It might take a little while, but don't worry. So there you go. So this was the sheet 2 where we created the diagram. Don't worry about that. Now we need calendars table, locations table, people's table, products table, and the shipments table. So shipments is the fact table. Calendar, locations, people, and products are the dimension tables. Now, this particular data that we have is fine. We don't have to do any data cleaning. This was previously cleaned and processed data. So we can directly load the data from this stage. So let's click on the load button, and it will take a little time to load all these data models to Power BI. So there you go. You can see calendar, locations, people, products, and shipments are loading. And you can also read creating connection in model. So data modeling is already happening. So detecting relations, 670 rows loaded successfully. So on the right hand side, you can see the data, right? If you scroll down, you can see calendar, you can see locations, people, products, and shipments, right? So these are the basic entries that we are having. Now, what are we talking about data model since so long? So here you can see the report view, data view, or the table view, and this is the model view. So if you click this, you will now understand why we made that diagram on Excel spreadsheet. So here, let me close this as well. So here you can see how the products table is related to shipments table, and how locations table is also connected to shipments table, and how the people's table is also connected to the shipments table, right? They create a star pattern, almost a star pattern, right? Now, you can see a star logo here, right? If I expand, and you can see one number here. So what this specifically means, this is many to one relationship, right? Many entries of shipments table are related to one element of this particular people's table, which is SPIT. Remember the analogy we discussed? That's what it is. So here, many entries of shipment table are related to one entry of locations table, which is GID. Similarly, we have the many to one relationship here as well, where many entries of shipment table are related to one entry in products table, which is PID. Now, the only data which is not connected still is the calendar data, but not to worry, we can connect that as well. So here we have calendar date and here we have shipment date. All you need to do is click and drag this particular element to calendar date, and you can establish a connection. Now, here you have a new relationship. So Power BI is showing you this kind of relationship can be established between the two tables. Now you need to cross verify of the elements you're choosing, ship date and calendar date. Once you're satisfied, you can proceed. And here you have by default many to one because Power BI's model was able to identify which kind of relationship can be established here. But in case if you're not satisfied, if you want a different approach, you can also move the cardinality from one to many, and many to many. By default, it is many to one. Let's keep it that way. And you can also go with cross filter direction, which can be single or both. For now, single is enough and single is the one recommended. So let's keep it that way and save this, and you'll have a relationship with this particular element as well. So one multiple elements of shipments table is related to one entry, which is calendar date in this particular module. Now let me uh, lesser the size. Let's zoom out and zoom in. So that's how the relationship looks like. Now apart from this, you also have properties, which helps you understand what kind of relationship has been established between any two tables here, the cardinality, and you can also manage relationships here. So here the shipments GID has got many to one relationship with locations, and shipments has many to one relationship with PID, and shipment ship date has many to one relationship with calendar, and shipments SPID is collected to SPID in many to one format as well. Now you can close this, or you can also add a new relationship or edit an existing relationship or filter any of the relationships present here. Let's close this for now. And apart from this, you can also create a new calculated measure, new column, new table, calculation groups, and you can also manage the roles, view as, right? Basic functionalities. Now you also have the data details here, data model. So you can go and take a tour. Now let's close the model view and go to the report view, where you can create sample charts. For example, I want to know the geographical location, or we can also go with the Q&A visuals. If you double click, the Q&A will start here, and you can just simply type what are you looking for. I want to know category wise sales in region, geographical region. Category sales region, and the type of chart could be bar. Now you just wrote simple English language, and the Q&A is trying to understand what are you looking for, and it will try to generate a visual for you. Or you can give it a moment and try to do it all by yourself. So I would like to go with bar graph, or you can go with the pie chart as well. And now what you can do is add geographical location. Since we're dealing with geo, why should we not go with map? You can also go with map, but that's not nothing to worry about. So what you can add is you can add this here, and you want values. So I want to go with the summation of amount, order status, monthly status, total sales. So I want to go with summation of amount, and it will be added in values. So here we have a readily available visual. So we sold about 23% to UK. So you can also add tooltips. So I'll add geo to tooltips. And in India, we sold about 23% of the sale, and in USA we had 17% sale, and in Australia 17.47, something similar, and in New Zealand we had 12% of sale, and in Canada we had about 5% of sale, right? So apart from this, you have a wide variety of other visualizations as well, like slicers, funnel charts, cards, and a lot more, which we will be exploring in the upcoming modules. And with that, we have come to an end of this module on data modeling. In the upcoming modules, we will deal with DAX calculations, basic visualizations, and building an interactive dashboard. So now we enter our next module where we will learn the DAX expressions. So DAX stands for Data Analytics Expressions, but for some reason instead of taking DAE, they took DAX. And simply, the same DAX is also as complicated as the naming convention. So we will have a lot of, let me cancel this. Yeah. So we will have a lot of naming conventions in DAX, and also we'll have one common misconception if you're a total beginner or if you have transferred from Excel to Power BI or any other platform to Power BI, then obviously you'll definitely have a small misconception that DAX is all about some basic aggregate functions like sum, average, mean, median, standard deviation. But it is a part of that. Apart from just being an aggregate function, DAX has a lot of other things to deal with. So, in simple terms, DAX provides you a lot of freedom when it comes to deep diving into data analytics. You can kind of write your own mathematical logic. If you understand your business requirement, yeah, to be honest, before you dive into DAX, you need to understand what is the business perspective of your business owner. If you are the business owner, or if you're working for an organization, then your organization's business perspective, you need to have a good stand on that. You need to be able to understand what your business owner or you as a business owner is expecting from your data, right? Once you have that particular clear vision, you need to extract the data and clean the data. Unless you have a clean and perfect data, writing DAX would always end up in miscalculations. Let's say for a simple example, if you wanted to divide a certain column with another one, if you had zeros in it or null values in it, obviously if you're directly dividing column A by column B using a slash, and definitely you'll end up into zero errors, right? The error that you get divide by zero, correct? If you change few things in the same division function, instead of writing a slash, if you write divide and the column name, comma, column 2, then you might not end up with that zero error, right? Divide by zero error. So few minute things you need to keep into consideration when you're dealing with DAX. That's one thing. And apart from the regular average or sum or aggregate functions, there is a lot to deep dive in measures and all the DAX functions. So with that basic understanding, let's dive into the DAX functions. Now let's create a blank report, and here we will be working with the same dataset that we worked on the previous section, that is the sales example dataset. So we will be having the calendar, location, people, products, and shipments. Let's give it a moment while the data loads. And apart from just the datasets, I would also highlight or some important things about the data modeling here. So when you're always working, whenever, just keep always this thing in your mind. When you're working with DAX, you need to have a good organization of your schema or the data model. Yes, previously we discussed that star schema is one of the most frequently used or one of the most important schemas out there when it comes to data analytics. But when you're especially working with DAX, then make sure that you are using star schema, but along with star schema, the arrangement of data sets or the data models is also important. It plays a very critical role. It kind of gives you a skeleton how the data is flowing and what it is happening in the background. So to understand this better, let's actually dive into the data model. So I've selected my tables, which is calendar, location, people, products, and shipments. So we want to go into transformation, or you can directly load. You don't have to worry about any kind of data errors in this. This is actually a cleaned data set. Since you're working with DAX, I made the cleaning and everything is good to go. So I'll directly press the load option here. And let's give it a moment while all the 5 tables load. So you can see creating a data connection in model and loading the data to model, relationships established, and all the rows are loaded successfully. Now, before we go into actual DAX, we should have a quick look on the model. So here, let me close data, let me close properties. So here you can see our fact table has been located in the center position. So let me reduce the screen size a little bit so that we have a good overview. So whenever you're working with DAX, make sure your tables are arranged in this way. So for example, this is a dimension table, right? So dimension table should be all arranged in the top position. So we'll just give it a moment. So this is our calendars table and this is our products table. And this particular fact table will be arranged here, right? So now why did we do that? You will understand which of these data tables or data models is a fact table and which is a dimension table if you go ahead with this type of arrangement. So this type of arrangement, just by a visual glance, you can understand which table is what and which data model is meant for what purpose. So make some quick arrangements so that you'll have a quick overview of what exactly you're dealing with when you're working in real time. So here we don't have an established connection with the shipments fact table with calendar. That can be done in a moment. Just go to that one element which can relate to your calendar. So we should be having ship date. Yeah. So just like we did before, drag and drop ship date with the calendar date here. You'll be having a new relationship and Power BI will identify which are the columns which can be related here. So you can see it automatically selected ship date and the calendar date. And you can also see the cardinality. So let's go with the same cardinality by default provided by Power BI. So we have many to one to many to many, and one to many. So whichever cardinality suits best, you can choose that and go ahead with it. By default, Power BI has the caliber to select the best one for you. So I'd like to go with the Power BI's choice of cardinality here. And anyways, this is the one which we're looking for as well. So you can quickly save and you will have a well-established relationship between the calendar as well as the shipments table. So all the tables, let me expand this. So all the tables located up top are your dimension tables and the table which is located here is your fact table. And here you can see the relationships processed. So here it is many to one and all the other are also many to one. And if you expand this a little bit more, you can see the flow diagram here. It is flowing from the dimension table to the fact table. It means it acts like a filter. Let's say you wanted to filter out something from the locations table. So we have about 5 to 6 geographical locations and 5 to 6 geographical IDs. Let's say you wanted to know the information for a specific geolocation and you wanted to identify all the shipment track records for that particular location. So what this majorly does is it acts like a filter and it filters out the details for that particular geolocation. And similarly, the facts table will also change. It will only show the rows related to that particular geo ID only, not all. So similarly, here you have salesperson details. If you specifically provide a dedicated salesperson, the same filter applies and the data will be filtered. Let me drag this. So data will be filtered and accordingly the changes will be done on the fact table as well. Now that's how, or that's the reason why we need to arrange the data models in this particular module or this particular style so that you can identify which table is a fact table and which table is a dimension table. So I hope you had a great understanding of that. Now let's go back to the report view here and you can get started with DAX. So there are multiple ways since DAX is very critical and an important aspect of data visualization with Power BI. Microsoft has chosen to add multiple ways to select a DAX operation in Power BI. So here we have one option, which is DAX query view. You can directly access DAX from here as well, or you can choose to dive into modeling. And here also you have the calculations aspect or calculation style here. You can choose to create a new measure or create a quick measure. So nothing major difference between new measure and quick measure. So quick measure is the easiest way to create DAX or a measure which happens to be an aggregate. So if you wanted to create an aggregate function like sum of all the sales happened or the average of sales happened. You can choose those quick measures or quick aggregate measures through quick measure here. And if you wanted to dedicatedly write a DAX, then you can choose the new measure from here and write your dedicated DAX function. Apart from this, if you go back to home, you have another calculation tile right on the ribbon, right? You can choose to go ahead with new measure or the quick measure from here as well. Apart from this, there is a quick shortcut as well. If I go into shipments and wanted to write a measure, I can also do this from here by right clicking on amount, and you can see we have a new measure on new column option here as well. So which is also one of the options to create a DAX. So with that, we have a basic understanding of how exactly DAX works or how exactly you can navigate through DAX. Now, whenever you're dealing with DAX, you'd better if you're new to DAX, then I'd recommend you better go with a table visual so that you'll have raw numbers and you can understand what exactly is happening on the go. Now, to understand DAX better, let's start with the picture which we already have in our mind. DAX is just aggregate purchase. So let's get started from there. So on the go, you will understand how it actually differs from our picture that we have in our mind. So if you're coming from an Excel background, then definitely you might think DAX is just another aggregate function, but it's not. So it's a lot bigger and different from that. So for having a comfortable understanding, let's anyway start from that particular aspect. So let's try to create a DAX here, which will be this one, and we will have a formula bar there. So to have a better visuality, I'll expand this particular thing. So you can just hold control and scroll up and down on your trackpad, or you can also use your mouse scroller to increase or decrease the size. So if you are proceeding with DAX, then you also need to understand the syntax of DAX. And by the way, on the flow, when when you've already created some DAX for yourself, then those DAX will act as your primary asset. And when you're reusing that particular DAX, the syntax might change a little bit, not too much. But anyways, let's start with the fundamental syntax. So any DAX will have three particular parts. So the first part will be actual name of the DAX, which is total amount that we have added here. The second part is nothing but this particular small logo or symbol, which is equals to symbol. And the third part is nothing but the mathematical logic that we are about to write. So let's start with that simple aggregate function. I want to use a sum of, I want to go with shipments table. So I have shipments. And here I have a shipment amount. So I want to go ahead with that particular point here. So you can either choose to write the entire name, or you can also use the tab operation on the keypad. So just click on tab and it will be selected for you. Make sure you close the last bracket and enter. So you have now successfully created a new measure. Now you might be asking me, why did I do this when I have the option of directly dragging and dropping this particular amount column from the data table? So let's also go ahead with that. Now let me add the product ID to the table. So we have added the ID rows and the total amount to this particular one. So there you go. Let me expand this. Yeah. So we have yeah. So we have the total amount here. And apart from that, we have sum of amount, which we created using an aggregate function. Now, if I drag and drop the total amount DAX, which we created just now, we will have the total amount as well. Now, you might be wondering, why did we even create this? Why did we even have DAX when we already have aggregate functions available on Power BI? So this is where the point comes into picture. DAX give us a lot of freedom rather than the aggregate functions give us, right? Now, if you see, there is no difference between sum of amount and total amount here. But if you look into this particular aspect, which says formatting option, so you can go ahead with formatting. So instead of general, you can go ahead with currency, and instead of the decimal values of auto size, you can just decrease the decimal values and choose I don't want any decimal values, and then the decimal values will be eliminated as well. So I want to remove the zeros here, and I can remove those. So now you can see a clear difference between the total amount which we got from the aggregate method and the total amount that we got from our DAX method. So clearly, when anyone sees this particular number, they will automatically feel that this is currency related or sales related or revenue related or anything which is basically related to business. So it gives you a clear business point of view if you're using DAX. Now, apart from that, you can also go ahead with a lot more functionality to this, just apart from creating a total measure. Let's inspect that as well. So let me resize it. So apart from looking at this particular DAX as a similar looking language like aggregate functions on Excel, there is a lot more differences. So you might think the same sum function is also available on Excel or any other data analytics platform that you have already been on. So the difference is, for the purpose of creating similarity between DAX and the previous functions that you've already used, they are using the similar syntax, which is sum, bracket, and the shipment table name and the amount column. But deep down, it is like alphabet, right? You might have the same alphabet on your language that you're using, but the way it is being used is a lot different. So it's like you're having the template of English language to write the terms of other language. Let's say you wanted to write something in a different language like Japanese, but you don't know the script of Japanese. So instead of writing the term in Japanese script, you're writing the same term using the words of the English language, which might sound same, but the script used is different. So that's the difference between the DAX and the aggregate functions that you've already used to from the other platforms like Excel and everything else. Now, you might wonder, let's now create a new DAX and see if that particular DAX is already available in Excel or not to have a clear picture. Now, let me create a new DAX function which says count of rows. Let me create a new measure and we will name it as count rows on OWS equals to, or you can also name it as shipment count to have a better picture. Equals to count rows was a function. Yeah. So if you select this particular function, now you will be a little confused. I have never used count of rows in any of the data analytics platforms like Google Sheets or Excel, right? This particular function or a few other functions, as you can see on the set drop down here, add missing items, all except, all, no blank row, right? These are a few additional functions that you were never used to work on Excel or they were never available on Excel. But these are some additional functions or capabilities programmed into Power BI. So we are going to use one of those. So we will be now tracking shipments. So I'll drop down shipments and this is the measure I want to add and enter. Now we have a new measure and this you can see. So the major difference between any of the dimensions and fact tables here and the DAX table is you can see a small calculator logo in front of the DAX that we have created, right? So whenever you find that logo right in front of one of the data models or the columns here or the data items present here, then you should be identifying that particular entry or that particular measure is a DAX measure. Now you also might be wondering if this particular DAX measure is available in the data model or not. So, or the table or not. So if you go into data model or the table view here, if you look at the shipment table that we just created, this particular shipment table, you have all the original values, the shipment ID, shipment as salesperson ID, PID, graph or geographical ID, ship date, amount, boxes, and order status. But the measures that we created right now, we created two new measures. One was total amount and the other was shipment count. So you cannot see those items here, right? You cannot see those two DAX columns here. So it's like an added layer on top of your existing table. This particular layer can twist and turn the data. It can, kind of stress your data to extract the insights, but it will never be a part of your data table. So that's the functionality of DAX. Now, let's go back to the visualization page or the report page, as you like to call it, and try to do some evaluations on this. Now, if I drag and drop the shipment count to the data column here, I can see what are the number of shipments made by each and every employee from a person level or a product level. I think we have added PID. So from a product level, so for better clarity, I'd like to also drag and drop the product name here. So I'll drop product name. So based on this product name, I have so many sales, right? If I directly click on this particular aspect, I can reorder or we can sort this particular table. So you can see product 4 was one of the highest selling products. So we have highest selling shipment counts in this particular product. So this is the independence that gives you. Now, if I close all these things and reduce the size of my table, or here we have it. Let's try to make some space for a visualization. So you will clearly understand why DAX is so important for us and what's the freedom we are getting from using DAX. That's the one. Let us include one of the visualizations here. I'd like to go with bar graph or a column chart, whichever is functional. Let's go with this particular one, column chart, and I'll have this column chart on the, okay, not this one. Let me unselect this and have an additional, yeah, this is the one. Now, if I select the geographical location and add it to x-axis and then add the shipment count to y-axis, you will have a visualization, right? Now, how is it different, or how is it making so much amount of difference? But let me uncheck this. So now you will have geographical location wise data for the total amount of sale done and the total amount of shipments done. But would you have, if you, just imagine if you had used a regular aggregate functions and if you wanted to find out the details for a specific product from a specific location, was that available for you? Unless you had a filter. Yeah, you might be telling me that if we add a filter or if we had a slicer inserted into this particular visualization, maybe we could have done it. Yes, but could you hard code it to a slicer? No, right? Slicers doesn't work that way. You cannot hard code slicers to one particular aspect. It's like a switch on and switch off kind of a tool. If you click on one particular product from a slicer, it will show you the data related to that particular one. And if you automatically switch to a different one, you cannot keep that data anymore on your visualization. But in terms of DAX, you don't have to implement any type of slicers for your visualization. It is directly hard coded into your visualization. Let's imagine I wanted to find out the total sales happening for UK region. So if I just click on UK region, I have that particular sale value. And let's say I wanted to go ahead with a specific product. Let's say I wanted to go ahead with product 4, then automatically I'll have the details related to that particular fourth product ID and the sales happening in geolocation UK. So that's the power of using DAX in data visualizations in Power BI. Now, Let's explore a few more DAX functionalities in Power BI. So this particular change or this particular interactivity that you find in DAX is called as, or it can be termed as, evaluation context in technical terms. So the evaluation context here is the background process, what's happening when you're trying to filter out data without using any type of slicers or filters. Now, let's go with another type of DAX here. Let's say I want to calculate total boxes. So let's leave this page and create a new page so that we have a cleaner looking data. Now, what I'd like to do is I'd like to add a DAX function. So you can go ahead with adding new measure. So this is easier for me. You can also go ahead with clicking right click option here and writing a DAX function, whichever suits you better. So we have multiple options to create a new measure. So I'd like to go with this particular option, create new measure. And here, my new measure will be total boxes equals to, I'll use an aggregate function, sum of shipment table and shipment box. So here you already have the table and the column name. I'll just click on the tab button, close the function and enter. Now I have created a new measure which says total boxes. I think it went into the calendar table, but we don't want it to be here in this model. We want the total boxes model to be present in the shipments table. So let's collapse all these. And now I want a new measure to be created here. Create quick measure, create new measure, and the formula will be same, total boxes equals to summation of shipments table, and the column will be boxes, close the, so the column name will be boxes and close the ampersand, hit enter, and your new measure has been successfully created, which is total boxes. Now, why did we create this particular measure of total boxes? We are trying to find out how many boxes did each product consume to pack. Sometimes you might be having a very big product, right? And for that very big product, you might have to, parcel it in terms of assembly, right? A part of the product in a box, a different part in a different box. Let's assume that you have a very big inventory, and in that very big inventory, you have one product which is bigger or the biggest of all. And to courier that particular product, you might need multiple boxes. Let's say our biggest product will need 3 to 4 boxes to courier it, right? And there is another product which is equally or a little bit smaller than that, but it is foldable, or it is in a way retractable, and it needs only one box. Now, we're trying to identify that one particular product which is consuming a lot of your inventory just for packaging, right? In that particular aspect, if you find out that particular product, you might be looking for an alternate so that it saves you on packaging. So that's the business point that we are trying to deal with here. So for that, let's drag and drop, or let's create the same table vision for us. So we'll have a table here, and we will drag and drop product ID or product name into the table, and then the recently created DAX, which is total boxes. Now you can identify, you can see, or if you rearrange it, we can see product 4 is that one particular product which is consuming a lot of boxes to courier, right? And let's also see the total amount it is getting us. So let's have total amount here. Now you can see it is earning us about $33.2 million with such amount of boxes consumed. And let's rearrange this. So if you can see, we also have product 22, which has, okay, let me expand this a little so that we have a clear picture. So here you can see, earlier we shows product 4, which was giving us 32 or $3.2 million with using the highest number of boxes. But here, comparatively, 1/4 of total packaging, we have the most highest profit from product number 22. Now here, what we achieved is, we need to identify which is product 4, and we need to look for alternatives so that we can save a little bit of money on packaging and couriering the product, right? So this gives you a clear picture of business aspect that you must be looking into, right? DAX is the one which gives you this freedom or this level of freedom to identify and execute some business decisions. Now that we have understood the reason for this particular freedom, let's dive into the next aspect of today's DAX, which is DAX reusability. So this will take us back to the point 1 where we discussed about the syntax of DAX, right? So we initially thought the syntax would be different, right? So we will be having a DAX name, the second part will be equals, and the third part will be the table name and the column name. Now comes the part where we discuss the differences, right? There will be a little difference in this particular approach where we will be reusing the already built tags. Now, you can also go ahead with the standard procedure of using the table name and column name, but the reason for not going with the standard way is different. So this gives you an advantage, an edge to identify which is, so we have two types of functions. Basically, whenever you use an aggregate function or the function that Power BI provides you, that particular function is called as the implicit method, and the one you specifically write is called as the explicit method. So when you are using a calculated DAX for recreating a new DAX, then you will identify this particular method is already an existing DAX and it is a measure. And in case if you're using a table name, that means you're using a specific hard-coded table name. That helps you differentiate between these two approaches. That's the reason why we don't go ahead with the standard approach of using table name and column name when you're trying to reuse the existing DAX measures. For example, let's go ahead with identifying which box had more boxes per shipment. So here we had created right total boxes and total amount. So for identifying boxes per shipment, we will create a new DAX. So let me expand this. So let's create a new measure. And we will call this particular measure as boxes per shipment. So it's similar to the previous approach or previous calculation we did. So boxes per shipment can also be calculated by using the total boxes. We created a total boxes thing here, right? You can drag and drop this particular thing here, or you can total boxes. So the key identifier that if you are reusing a DAX or if you are reusing or using a column name is this. If a formula starts with box bracket, then or square bracket, that means you're using a DAX. And if you are using the normal parenthesis, then it means that you're using an existing column. So total boxes divided by shipment count. So shipment count. So this is the one. Press tab to enter. Now you can close the parenthesis. I think we did not create a parenthesis again. Okay, that's fine. Press enter and your new DAX or the DAX which has been created by reusing the existing DAX is created here. Now what you can do is you can drag and drop boxes per shipment and identify maximum boxes per shipment. So if we rearrange this, just click on this particular aspect and you can reorder. Now you can see the product number 18 actually used a lot of boxes per shipment, right? And the initial aspect where we identified total number of boxes. So yeah, I think now we have a clear picture. Previously, we misunderstood that the total number of boxes used by product 4 were highest. But when the final packaging comes, there is a possibility where the exact number of boxes could be a little different, right? One huge box might have smaller boxes inside it, right? It's like an abstracting process where you package every minute item into a small box and all those small boxes will be packaged into a large box. Now this particular thing, what we have here, gives us a better advantage. Now you can see obviously 4 lakh 80,000 or 480,000 boxes were used to package product number 4, but at the final count it is using 753, which is a lot closer or lot similar to product number 18, right? So here you can see a minute difference between the two packaging. So that is the level of detail we can get into by using a little bit of tags for business purposes. Now, if you proceed a little bit into details, then the next thing we can calculate is amount per box or amount per shipment. So let's create a new measure, and I want to identify amount that we are spending per every single shipment. So amount per shipment is equals to. Now, remember the divide function we previously discussed about. If you might have, maybe there is a possibility that you might end up having zero value in the second column, right? The column which goes under the denominator section. And if you divide such particular numbers, you might end up with divide by zero errors. To avoid that, you can simply call a divide function here and mention the columns that you want to divide. So here we will send out two particular columns or tax calculations. So total amount is the tax calculation that we previously created. And the second value is people. So we'll be using people table here. Or I can write down salesperson. We have a people table, right? So why am I not able to identify people of salesperson? Okay, let us try that differently. Anyways, we have the amount spent per packaging here, but we just wanted to explore a little bit of DAX reusability. Let's try to hard code that. So under people's column, we have PID salesperson. Okay, let me try this particular approach. Salesperson, still unable to identify. Let me create an parenthesis and type the table name. No use. But anyways, we have the shipment per box here. Let's close this. Let's deny this or cancel that particular DAX. But anyways, now we enter into one of the important functions of DAX. Now, this could be a game changer for you in perspective of business analytics. So that function is nothing but calculate. So let's create a new page and enter into the new page and try to create some functions, DAX functions using the calculate method. Now let's say I want to identify the amount of sale did or done by each person. So for that, I'll write a calculated or calculated field or new measure. So I'll go with this particular aspect. I'll create a new measure in the people's table, and the measure will be named as employee amount equals to calculate total amount, comma, people and salesperson. So previously we did not find this, but now Power BI was able to find salespersons. Some unexpected error, not a big deal. So apart from this, I want to find out for a specific person. So if we go into the tabular view, And here we have Emily Davis. Let's say I want to calculate the total sale done by Emily Davis. Study hard set or copy this particular name and go back to report view. And where is our, this is the one. So we need to edit this particular DAX function, and salesperson is equals to, we copied, okay, I think we have everyone here. So let's erase all those. So I want to keep just Emily Davis here. So you can again come up with a new idea, or you can again come up with a new doubt where you can say, why use a filter in DAX if we already have a slicer, right? So you can do with this using a slicer, but as we discussed, when you use slicers, the slicers behave like an on and off switch. So when you switch from a different person, automatically the you know uh, the control will also switch from an existing person to a different person. Now let's compare that side by side. Now this is my DAX and I'll enter, and we have the DAX. Now what we can do is we can drag and drop product. So let's create a new visualization. So we can drag and drop product and sales done by Emily Davis, and also we can have a salesperson as well. And if I drag and drop the amount once again, so here you can see the difference, right? In the first section, we selectively filter Emily Davis and the number is as is. And when it comes to the second filter, you don't have a filter here. You have all the data excluding Emily Davis and everything is normal, right? So this is the main difference that we are dealing with. So apart from this, if you wanted to identify the specific number of sales done by a dedicated employee, then you can create this calculate filter for a dedicated person in a many number of ways. Now, let's head into one last approach for DAX, where let's say we have a target and every employee has some target, and we want to find out if that particular employee has achieved the targets or not. So let's go and add a new measure, and the measure will be named as sales target. And sales target is equals to, let's say, 1.5 million. So hit enter and we have sales target here. Now let's create a new measure. It's like an if condition. So if the sales target is achieved, then fine. If not, you mark it as not achieved or something like that. So we will create a new measure and we will write the measure as follows, as performance is equals to if condition total amount. So total amount is greater than sales target measure. We're reusing the measures again. Then you can write it as target achieved, else not achieved. So this will be my DAX and hit enter. So I've created a new DAX here. Now what we will do is we will drag and drop, we'll create a new table and we will drag and drop salesperson onto the table and total amount that we have done. And we will also add that performance DAX calculation that we created. And now we have a clear picture how many number of employees have already achieved their target and how many did not. For example, here you can see Carter did not achieve his target, and Eva Lewis did not achieve her target, and so on. So the minimum bare number that we wanted to keep in order to find out if a target is given target is achieved or not was 1.5 million. So there are people who already kind of overachieved, and there are a few people who did not achieve their target. So there are multiple ways that you can include and try to work on with using DAGs. It gives you a lot of freedom than the basic implicit functions that you already get from Power BI, like the aggregate functions like sum, average, mean, and median, right? Now let's consider a small use case for you. Now let's also find out, uh, consider this as your homework. Now, just like we had the target for salespersons, let's have target for product as well. Or you can just simply write the DAX commands that you're going to perform on your Power BI in the comment section below. So write down a DAX function to find out the product's target. Let's say the minimum product sale, the minimum sales for a product is about 500, and find me out the products which achieved their target and which did not, so that we can find out the performance of product visually and identify which products needs a little bit of marketing and which are the products which are highly performing, and we can slightly increase the rates so that we can get a little bit of profit out of them. So this brings us to the end of module 7 on DAX basics. So let's continue with the next module where we will find out interactivity and drill downs, or basically creating a fully functional dashboard. So now we enter the next module where we will be understanding how to build charts and add slicers, filters, and basically create an interactive dashboard combining all the learnings that we have learned so far and create a completely business oriented dashboard for interactivity and insights. So let's go with the Excel files for this particular data set. Now we have this particular Excel file here. Before we get started with the dataset, let me bring back our learnings where I used to tell you once you use, like, let's go back to Power Query once, where I said you there is this particular feature in Power Query where you just provide the location of the file once, right? Whether it is on a database or a server or a cloud, or if it is just a file location on your local system or anywhere, we just provide the location of the source and create some queries or create some steps for data cleaning. And after that, if you load the data to the platform like Power BI, the modeling or the data visualization becomes easier for you. And whenever you add new data to it, Power Query will automatically learn or use the learnings from the previous transformations and changes to the data set, and it will implement all those for you, makes the data clean, and you can just focus on data visualization without wasting any time on data cleaning or data transformation part. So we will be bringing that back in this particular demo. So here on my screen, you can see I'm providing a file name as location for our learning. So this location will have 1 year's data, which is very old, 2021's data. Let's assume that we have a business statement here, and we are comparing year on year performance wise. And here, if we come out of the location, here we have sales data for 2022, 25, 24, and so on, 23, right? They are ordered a little different, but not a problem. What majorly our concern is we are having 5 years of data, right? So we'll start our process of data visualization with one particular file, and then we will build an entire dashboard with just one file. And the magic happens at the last stage where we add all the new data, all this new data, what I'm talking about is, let me highlight them, all this new data into this file location. And once we add it, the dashboard, what happens in the background is Power Query will check all the data sets that we have recently added into the location, and it will reanalyze, rerun all the numbers and update the dashboard on the fly within a couple of seconds. So that's our approach. Now, the data that we are dealing with is here. This is the data set. We have sales data, so it is order ID, order date, on which date was the order placed, the delivery date, right? What was the delivery date, order status, if it is delivered or not. We have customer ID, we have customer name and last name, the state in which that particular product was delivered. We have this region, is it east or west, north, south, and central regions of the location, and what was the product, and what product or what category does the product belong to, if there is any subcategory for that as well, and the number of quantity, and what was the initial traffic to the website, and how many number of traffics converted into leads, and how many of those leads converted into orders, and what was the quantity, right? And we have cost to company and also revenue and profit. So profit is nothing but the difference between the cost to company and the revenue, right? You might create a product for 10 rupees and sell it for 12 rupees, then your profit is 2 rupees. That's how revenue and profit and cost to company matter. So this is the overall basic agenda for our dataset. And this particular dataset is already cleaned. So we have split customer, first name, last name. And to reduce the length of this particular demo section, we have used the clean data, and you already have a good understanding of data cleaning, modeling, and DAX functionality so far. So we will be directly ingesting this data into Power BI platform. So I hope you have a good understanding of what kind of data set are we dealing with. We are dealing with sales data. We have order details, customer details, location details, and the traffic, lead, orders, revenue, profit, and quantity details in all in one shot. You don't have to, kind of create joins or merges. We also dealt with the joining data tables, merges, and how to append the data, and we don't have to work on all those complicated things. We can just understand basic functionality of how to create data visualization on Power BI platform, how to have a good background, a user interface. You'll also, so coming back to user interface, let me show you one of the interfaces that I created. So this particular image that you're seeing is created for user interface purpose only, user experience purpose only. So when you directly go into Power BI, you don't have such a beautiful, if or a good, decent, if not beautiful, a decent background. All you get is a plain white background, but it doesn't end there. Power BI gives you an opportunity to add or customize your own background to elevate the user experience for business leaders. So the main, you need to understand what is the business purpose of your organization. So the purpose of this particular example is the business leaders wants to identify what is the traffic they are dealing with on monthly basis or year basis or provided date basis, and what are the leads. So here you can see we have state, year, and month. We can drill down. So we'll also go through drill down and drill through options. So we can drill down the sales date into years, into months, and dates as well. So here you can see month and year. So we can have that as well. So the business leaders wants to identify in a dedicated state, in a dedicated year, in a dedicated month, how was the traffic, how were the leads, how many number of orders did we receive, what was the revenue, and what is the quantity of orders did we receive. And if you scroll down a little bit, you can see region-wise sales, north region, south region, west region, east region, and central region, and category-wise sales. What category of products sold most in what region, segment-wise sales. So if you go through this, you can see how detailed this particular approach is. You can find a product level data, you can find subcategory level data, you can find category level data. Apart from this, you can also find out location wise data, which state had particular product sales high or low, which region of that particular state had a dedicated product high or low, right? And also you can see geographical location here, which is the biggest box. So in this biggest box, we will have one of the visualizations, which is geographical visualizations, or also called as map chart. And here at the last, you have month-wise sales performance. So one thing to remember, whenever you're dealing with date-related data, if you have one of the measures or one of the dimensions as date, then it is by default, you should be going with a line graph, because line graph is the one which shows you the performance, if it is growing, if it is spiking, or if it is dipping, right? That's the purpose of using a line graph whenever you have date. So remember that. And rest of the ones, when it comes to the first row, state, year, and month, you can go ahead with filter or slicer. We'll also be customizing slicer. So the best part of this section is you can see the minute details, how, the slicer level things, the background for a slicer, the color for a slicer, the drop down choice, right? For a slicer, you'll be having a vertical box. You can customize that to a drop down. You can also ingest a feature where you can have a search bar logo on that, so that when you click on search, you can simply type which date you're looking for, and it pops out, filters out for you. And the same can be implemented for year and month. And you can also add KPIs, right? Cards are used for KPIs, key performance indicators, right? When to use cards, when to use a donut chart, when to use pie chart, when to use a bar graph, or when to use a column graph. Or apart from that, you'll also have a few more other alternatives like, a stacked bar graph, etc., and map chart. So you cannot use map chart for a bar graph, right? So the experience of using a dashboard matters a lot. So you can use, let's say, traffic by you can use a donut chart for indicating traffic. But will the purpose of indicating KPI be satisfied? No, right? So that's the basic sense you need to have. What kind of chart is created for what kind of indicator on a dashboard? When you're going ahead with KPIs, then cards are the best indicators. And when you're going with region wise state, like when you have less than 5 dimensions or measures, it's better to go with the pie chart or a donut chart, because it gives you the accurate amount of division of sales between the regions. So in regions, we have about 5. So we have north, south, east, west, and central. So this type of chart or this type of measure can be depicted using a pie chart, which has better visuals. And same goes with category. We have a couple of categories like 5 to 6. Then you can go ahead with a donut chart and segment wise sales as well, right? You need to have that simple understanding of what kind of chart is best suitable for what kind of representation of data. So this comes to the user experience and interface section. So you're free to use any tool for creating better backgrounds. I've used PowerPoint for creating this particular picture. You can use Canva or any online tools. You can also write a prompt to your ChatGPT and share the data with it, and share your business request or the business owner's requirements, so that it creates a good user experience or user visual for you, and you can download that and replace that with the background. So that's about it. So apart from this, we also have few other visuals. So here I have a social media dashboard. So you have follows, views, likes, shares, comments, right? If you're dealing with social media platforms, then you can go ahead with this one. So here we have buttons as well. X for Twitter, Meta for Facebook, Instagram, Snapchat, and YouTube. And you can also select the platform, state, region, resource. So we have this entire end-to-end tutorial on our channel. So you can also go through that. If you require this particular link, you can also comment us, and we'll share the dashboard with you and the tutorial with you. So we have a lot of different varieties of approaches for building a dashboard. So this was the one which we will be using today. So this is also one of the dashboards for creating sales one, and this is the one which we will be using today. So now with that, let's go to the Power BI platform. So let's give it a moment to load. So there you go. And we will be using a blank report for this one. Let's open a blank report. And to get data, we have a lot of options. Let me cancel this out. So to get data in the Power Query section, we have understood what are the different variety of sources available to get the data from. So here, I will not use Excel directly. What I'll do is I'll go to more options. And from here, I will have an option which says folder, right? When you select folder, it will ask you for the location of the folder, for the path of the folder, right? So you can open on browse window. Then your data is in downloads. My data is in downloads. You might have a different location as well. So here, or what I can do is I can cancel this. I can directly go to the window where I have my data. So it's easier for me to navigate. So it's in PBI, and in location. So just copy this location. This is my location. Go back to Power BI platform and just paste the location over here and press OK. Now, what happens is Power BI will automatically understand which data is supposed to be loaded. So here I have the data set. Click on it. So there has been a small error. So let's try that once again. I think it took two sections or two rows. Must be a smaller, don't worry. Let's give it another try. Yeah, there is a small error here. Let's try that. Yeah, we need to drill down. Just click on that expand button and it will expand the data for you. And now select the sheet. This is the preview that we were looking for. And I think everything is good to go as this data was considered the best one. I mean, it was already cleaned. So let's anyways have a quick preview. So we have order ID, order date, delivery date, order status, customer ID, customer name, and state, region, product, category, subcategory, quantity, traffic, leads, orders, cost to company, revenue, and profit. So as we discussed during the tags module, unless you have a clean data fully functional for analysis, you cannot proceed with analytics and it will not make any sense at the end of the dashboard. So I'm satisfied with my data. I want to click on OK for loading the data. So we have almost everything that we were looking for. So if we go back to data table view, I want to delete this particular one and go back to home. And I would quickly refresh the data. Now to the visualization train, and everything is now good to go. Now we will start with applying the canvas settings or canvas background. I would like to browse the picture. Can I keep it? So this was the one. Click open and image fit will be fit and transparency will be down so that we have a good visual. Discard the changes and we are almost good to go. Now that we have a good background, we will start with making the visualizations. So first we will come from top to bottom. So the top section is about including a state level slicer. So what I'll do is I'll go to the visualization screen. So here we have a wide variety of charts. We have stacked bar chart, we have stacked column chart, we have clustered bar chart, we have a clustered column chart, and then we have a 100% stack chart. This is the column chart again. So this is the line graph which I was talking about. This is the area chart and the stacked area chart. Next is 100% stacked area. This is a combination of both column chart as well as a line chart, and there is a different purpose for this as well. So each and every chart available here has a different purpose. So this is the ribbon chart. This is one of the waterfall chart which we most commonly use, and then here we have a funnel chart, then the scatter chart. So scatter chart is really helpful when you have the comparison performance, right? So if you have let's say employees performing date to date, then you can go ahead with scatter plot. So it shows you an indication of growth as well as a performance on a dedicated spot. So the performance is spread in dots in the graph. Yeah, so you can go ahead with that. and the pie chart, donut charts that we discussed before. And we also have a tree map chart, which is similar to not stack, similar to pie chart and the donut chart, but the only difference is the representation will be in the form of blocks. And here we have the map chart, the geographical locations, and we have the filled map chart as well. So both stand same, but if you use map, the fill will be indicated in terms of a dot. But if you go to the filled map, you'll have fully filled geographical locations. And you have Azure map, you have a gauge here, and these are the cards. And next is multi-row card. Then this is the KPI indicator, the slicer, the regular table that we use, and this is the one, the matrix chart. We have R script visual, Python script visual, and we have key influencers and decomposition tree, Q&A questions as well. You can include this in the dashboard, and you can try to ask questions. Like, let's say I want to find out which product sold best in provided state in a provided year. Then you can quickly get that particular visual. This acts like a chatbot for your dashboard. That's a very good feature in Power BI. And then we have narrative, which explains or which gives out the narratives on the performance of dashboard. Then we have metrics preview, then we have paginated report, then the card and new slicers and all the other things, which is AGIS Maps for Power BI, Power Apps for Power BI, and this is Power Automate for Power BI. So Power Automate is a whole new segment of learning. So we have a completely dedicated tutorial on Power Automate. So you can drop us a message in the comment section below so that we can share you the Power Automate tutorial for Power BI. So, and apart from that, if you see here, we have drill through and cross report options here. Now, let's get back to the dashboard and try to add the slices that we were discussing about. So we will just click on the slicer, and we have a slicer option right here. And let me drag and drop somewhere else. Now, here we will go into the visualizations format of this particular slicer. So let me drop the state location. So here we have now we have visuals. So we'll go into general, and I think we don't need a title for this one, so I'll keep it off. And we'll also go with the background. I don't want any background for this since we've already set it, and we don't want a visual border as well. And shadow, I think we don't need a shadow. Header icons, I don't need header icons. And background is also turned off. Transparency is 100% complete. Title is done. And properties, I think I'm almost satisfied with what I have. Now, apart from that, if we come into slicer visuals, I don't want the slicer header. And if we come into slicer settings, remember the drop down setting we spoke about? I don't want the vertical list. I want a quick drop down. So now I'll try to make it fit in the section where I, created the state. So this would be it. So I'll try to rearrange it to fit into this particular space. There you go. Now what I can do is I can also include the search icon. So whenever I click on the drop down, I have a search bar over there. Let's say I want to find out maybe Madhya Pradesh. I can just type down Madhya Pradesh and I'll get it. So now that the slicer is fit and done, now what I can do is to save time, I can just copy and paste it, right? I have a new slicer altogether. I'll just drag and drop this particular slicer to here. And similarly, I will copy this again and paste. Now I'll drag and drop this to let me select it to month. So the only thing that we will be changing for this particular slicer is, so instead of state, we will be selecting year. So we have order date hierarchy here. So if you open the hierarchy, you can select year in place of state. So we'll unselect state. Now we here have all the years. So for now, we just have 2021. So remember, we just selected 1 year per this particular visualization. So we will unselect state and we will open data hierarchy. So for date hierarchy, and then we will select month. So now we have all the states, all the years, just 2021 for now, but it will increase to 22, 3, 4, 5, and 6 later on. And we have all the months for the month section. Now the first slicer section is done. The next one is the cards. So what you can do is select a card, and this particular card will have the number of traffic. So you can see Power BI was able to calculate, the summation. So it automatically aggregated the total traffic happened. So now we will go into visuals for this one. So general, and we want header icons. We don't want effects, so background will be turned off. And apart from that, we don't want shadows and everything. So if you go into visuals, so here we will be having the category label. So we don't want category label because we already have a category labeled implemented into the dashboard itself. So we will drag and drop it somewhere here. And once you're happy with the location, the same thing what we did for slicer can be replicated here. So you can just copy and paste it. And now what you'll do is drag and drop to the leads section. You can also auto align that. And you can do the copy paste once again, and you can auto align to number of orders, copy and paste for revenue. So you can auto align for revenue as well. And one last copy paste for quantity. So copy and paste, auto align, and you have the quantity. Now what changes is in leads, you need to unselect traffic and you need to select leads section. So here we have the summation of leads, and in the orders section, you need to unselect traffic and select the total automation, which is the aggregation for orders. Similarly, you can go to revenue, select the revenue summation and unselect traffic. And last is the quantity one. So you need to unselect traffic and go to total orders or total quantity of orders. So far so good. The first two rows are resolved. Now we have the region wise sales. Remember we discussed if we have 4 to 5 elements and not more than that, you can definitely go with a pie chart. So we'll go with a pie chart here. Okay, let me quickly undo that. Okay, now select or click anywhere on the dashboard, and now click on the pie chart so that you have a fresh pie chart there. Now what you need to do is we have legends, right? So I need to add region data into legend and values of orders to values. So there you go. Now you can go to the visualization. I don't want legend. I don't want. You can have detailed labels, however. And when it comes to title, I don't want title for this. I don't want header icons and tooltips. You can include, or if you don't want, you can also remove them. But I want detailed labels and any effects, visuals, background, and yeah, everything looks good to me. You don't have any background. Now you can slightly increase the size of the dashboard and make sure to fit it into the dedicated location provided for this particular visual. There you go. Now comes the category wise sale. So click anywhere on the dashboard, use a donut chart, and for this particular one, category. So where do we have the category? We have subcategory, and should be somewhere here. So we have the category here, and you can drop category to legends, and then you can order to values. There you have the category wise sales. Go to visuals, the same steps we did. We'll just have detailed labels, and title, we don't want the title. We don't want tooltips. Now you can close this, And just like we did for the previous one, you need to fit it into the space provided for this particular visualization. Now we have segment-wise sales. So for segment-wise sales, we have a lot of segments. So when you have a lot of segments, it's better you go with column charts. So I'll go with this particular column chart, and we have a column chart there. And now we will have segment in the X axis somewhere here. Look for segment. Okay, subcategory. I think subcategory, yeah, we do have a subcategory. Uh, I think we don't have a segment, but we do have a product. So I think it's better we go with product category wise, subcategory wise. So we have a lot of products, however. I think we missed out on the segment part. Or let's go to the table view quickly so that if we can find out we have any segments or not. This is the location, and here is the data customer. I think we don't have a segment, but that's okay, not a big deal. So in place of segment, we can include product, but we have a lot of products here. But anyways, in case if we apply a filter, let's say we apply a filter for a dedicated category, then we might drill down the products into a little bit. So let's have products there. Anyways, so drag and drop product to x-axis, and we will have orders in y-axis. It might be a little segregated, or it could be a little compact for this particular space. So we don't want header icons, don't want tooltips. We can keep tooltips, but for now it's okay. And yeah, everything is plot area background. So do we have a plot area background? No. So this is good to go. And same as before, we need to size this to the location provided. Yeah, similarly, we have a subcategory as well. So you can click anywhere on the dashboard and then go to visualizations. You can include a bar graph, and then what you can do is simply drag and drop subcategory to columns, and you can add orders, total orders to x-axis, and you'll identify how many number of orders were placed by how many number of products based on products. So you can click the visual, and just like we did before, we can make some general changes to it. We don't want title, we don't want header icons, and we don't want tooltips and visuals. So we don't want any plot area background. So far so good. So let's select all. Just like we did before, we need to fill in the area allocated for the subcategory. There you go. Now, grid lines, we don't want grid lines. Slicer. Just check for each and every aspect so that your slicer or your, visual stands out. And ribbons, data labels, all the plot area. So the overall intention of creating a better visual experience for your end user is having a good representation of all the insights or visuals you build. So unless you take care of all these things, then you might end up in just another dashboard which doesn't look or feel good for the end user. So that now you have everything sorted out in one place. Now comes the next visual. So click anywhere on the dashboard, and then you need to click on the map, field map, or any map that you want, and then you need to open the data, and we will add state to the legend. And then what we will do is total orders, so that we will identify how many number of orders are being bought or are being received from entire location. So if you want roads, you can keep the roads. And general settings, we don't want title. We have already given the geographical location and tooltips. There you go. Now, or what you can do is you can quickly fill in this particular area dedicated for the map region. There you go. Now the last one is the sales month on month. Remember, whenever we are dealing with date to date, year to date, month to month, or last date today, remember the time functions that we discussed in time intelligence section. That's the one. So whenever you have time related data, repeat. So whenever you have time related data, go with line graph. So click anywhere on the dashboard, then go with a line graph, and your line graph will be created. Now on the x-axis, you need to drag and drop month. Inside the date hierarchy, you have month, right? So drag and drop that to x-axis so that you have month on month. And now drag and drop orders value to the y-axis so that you can see month on month performance. Similarly, go to the visual section and here check all the aspects and general section. And here we don't want title, header icons and tooltips. So everything will be provided by just one click. So just close this one as well. Now extend this particular graph to fill in the area dedicated to that. And here you have the tooltips. So I think we need the tooltips. So go to the visualization section and here go to, yeah. So if you add tooltips, then you'll have the values which are happening in that particular location, right? So now you have a completely interactive dashboard. Now is the best part. So let's say I want to identify for a dedicated location, right? So here I will select Delhi and I'll have the sales performance happening in Delhi right now. So we have about 17,000 traffic, and out of which we have 100, not 100, 1800 leads, 19 orders, and so much revenue. So we need to expand this a little so that we have an actual number. So we have about 647 revenue, which can be in millions or something like that. And this is the total number of orders we received, 207. And provided if you want to drill down a little bit, you can provide the dedicated month. So in the August month, so many leads were there, but no orders. So depends on the seasonal value also as well, right? So if you have April, then you might have okay, when you go into some other month, maybe June. So maybe due to some seasonality, like any festive seasonality, you have some orders. So based on that, you can achieve some orders as well. So apart from that, so if you unselect Delhi, and you'll have the overall countrywide sales, revenue, orders, leads, and quantity details. Now comes the best part. Now let's go to the data location once again. So I have my data in KVI and this is the location. Now what I'll do is select all these data sets, and what I'll do is simply drag and drop inside the location. I did not do anything yet. Now I'll close this and go to the dashboard. Nothing changed as of now. What I simply do is refresh the data. Once I click on the refresh data, new data is being loaded. Just click on close. Now you have the data for all the years. So if I click on year, so you can see automatically we have 2021, 22, 23, 24, and 25. Initially, we just had 1 year, which was 2021. So all the data cleaning that we did, like a quick review of what the data is looking like or what columns and rows we have, right? All that part has been done automatically or implicitly inside Power Query, and we have all the data ready for publishing or sharing with our business owners or your clients, basically. So now the next point is all about publishing this particular report or sharing this particular link to the business owner. And in the next section, we will be learning this. And that brings us to the end of this particular module on data visualization, charts, and adding interactivity, drill down, and all the aspects of a data analysis dashboard using Power BI. Welcome to module number 9. In this session, we will move beyond Power BI desktop and into the Power BI service, the cloud platform where you publish, manage, refresh, share, and embed reports at a scale. By the end of this module, you will be able to publish a .pbix file from Power BI desktop to the Power BI service and understand what is being published, which are reports, dataset, or model, etc. You can manage workspaces, roles, and the lifecycle of content and datasets. Configure dataset, which is refresh, including gateways, credentials, incremental refresh, and troubleshooting. You can also share reports and dashboards with users and teams effectively while maintaining security and governance. You can also embed reports into applications and web portals and understand the difference between embedded models and permissioning approaches. We will balance step by step, which is how to instructions with architectural reasons and governance best practices. So you know both what to click and why that choice matters in real business. So let's get started with part A of module 9. So the part A will be basically about how publishing works. So you need to navigate to desktop, then choose the service option. So let's start publishing. Publishing is the act of taking Power BI file, which is .pbix file you built in Power BI desktop and uploading it into the Power BI service, which is app.powerbi.com, where it becomes a dataset, a report, and optionally a data flow or paginated report depending upon how you build it and what you build, what you publish, when you publish from desktop, and how effectively you upload the three things. The report definition, the collection of page visuals, bookmarks, and layout. The dataset or semantic model, which is the second one, which is about the tables, relationships, DAX measures, metadata, and the connection strategy, which is basically how to import data query or a live connection. Then comes any query logic, the Power Query steps that you made, the produce data, the service stores, and the query logic in the dataset, so future refreshes can rerun the extract or transform steps carefully. Put simply, the report is the front end, the dataset is the engine, and the query logic is the recipe that builds the engine from source systems. How to publish step by step. So from Power BI desktop, you can either select the file to publish the Power BI option, or directly you can choose to click on the publish button from the home ribbon. You'll be asked to pick a workspace destination, select the workspace you own or have publish permissions to. The desktop app then uploads the .pbix file to the selected workspace. After a successful publish, you can open the report in the Power BI service and the dataset will appear under the workspace dataset section. Now, let's go through the key considerations when publishing. So firstly, the workspace choice matters. Don't publish into My Workspace, which is the default location for production reports. Use dedicated workspaces that you create for your teams, projects, or production apps. Workspaces map to content lifecycle and permission boundaries. A workspace should be the unit of collaboration and governance. We will dive into workspace roles shortly. So connection mode influences refresh and performance. If your dataset uses import mode, then Power BI stores a copy of the data and you must schedule refreshes. If it uses direct query or a live connection, the service queries at the source at runtime or caches limited resources or results, changing how refresh is handled and affecting concurrency and latency. So for this reason, it is better that you always choose the mode that matches your SLA and data size. Next is size limits and licensing. Large datasets and high refresh frequency may require premium or PPU capabilities. Check the organization's license and workspace capacity. If you run into file size limits, consider optimizing the model, where you can remove unused columns or use aggregations or move to a premium capacity. What to expect after publishing? Once published, your colleagues can view the report in the workspace if they have access, provided if they have access to it. The dataset can be refreshed on schedule and you can package the workspace content into an app to distribute to a larger audience. You can also download the report back as .pbix if permissions allow you. The service stores publication history and basic lineage. That's the publishing core. Next, we will look into workspace architecture and how to manage datasets after they are in the service. So let's go into the part B, which deals with workspace management. So roles, apps, and the best practices. Workspaces are the organized container in Power BI service. They hold reports, dashboards, datasets, data flows, and paginated reports. Workspaces are where teams collaborate, prepare apps, and manage lifecycle between development, test, and production. Now let's also take a look through types of workspaces. Microsoft has new modern workspaces which replace classic work pages. They provide better role control, governance features, and app publishing options. They create a workspace for each logical area or project rather than using a single workspace for everything. Now let's go with roles within a workspace. There are distinct roles you can assign to people and security groups. For example, we have admin. So admin has full control. He can manage workspace settings. He can add or remove members and delete workspaces as well. Then comes the member who has the permissions to edit content, publish reports, and create apps. Followed by that, we have contributor who has the right to publish and update the content but has limited management rights. Then we have the viewer who has only read-only access to the content inside the workspace. They can't edit or do anything with the report. Now, assign the least privileged role necessary. For production workspaces, use to publish apps, keep these sets of admins small, and use members or contributors for content authors. Viewer role is ideal for users who only need to consume reports without editing. Now, let's discuss the difference between apps versus the direct workspace consumption. An app is a packaged, curated distribution of selected workspace content intended for broader audience. It provides a stable URL, consistent navigation, and controlled access. Use apps when you want to distribute read-only content to a larger user base. Use workspace access when the audience needs collaborative editing or testing. Now let's discuss about the workspace lifecycle and governance best practices. So it comes from developer to QA, QA to production. Maintain separate workspaces for development, testing, and production. You need to encourage authors to publish to dev, QA, or validation, and then promote the production where you can republish or deploy the apps. Now let's go through the naming conventions. Name workspaces and datasets clearly. Include environment tag. For example, sales production, sales development, right? These are the tags you can use. And next comes the content endorsement. Use endorsement, for example, certified or promoted for trusted datasets to guide users towards single resources of truth. Certified datasets indicate governance vetting. Now let's go through metadata and documentation. Add descriptions to datasets and reports and keep a README page in Workspace with intended use. Data sources and owners contact as well. This will be helpful. Now let's go through monitor lineage and usage. Use Workspace and tenant usage metrics to track adoption and performance. Remove stale content and archive older versions. So let's go through an example. Imagine a company BI team supports sales reporting. You need to create 3 workspaces. First one, which is sales developer, which has only authors who build the reports. Next is sales QA, which has analysts to validate the report. And lastly, we have sales app, which is production app published to all sales managers in one go. Now, only a small set of admins and members exist in developer or QA teams, while the app is distributed to hundreds of viewers. Proper workspace management reduces confusion, enforces governance, and controls cost, which is capacity of usage. Now, let's dive into the part C, data refresh. The concept, setup, and troubleshooting will be dealt here. One of the most important operations after publishing is keeping your dataset current. Dataset refresh is how Power BI updates the imported data in the cloud so reports show recent information. So now let's discuss the refresh modes and triggers. There are multiple refresh mechanisms. So the first one is scheduled refresh. The most common one is this one. You can configure frequency in the dataset settings, which is based on hourly, daily, or even weekly. Power BI will run the stored Power Query steps and reload data from import mode datasets. Next is on-demand or manual refresh. You can run a refresh immediately after the dataset UI. Useful for ad hoc updates. Now let's go through push and streaming datasets. It is used in real-time scenarios where external services push the data into the Power BI. Followed by that, we have Power Automate or API. So this is actually a trigger refresh which happens through automation flows or API calls for event-based updates. This is useful when data source systems signal the data changes. Now comes the gateways and on-premise data. If your data source are on-premise like SQL Server, analysis services, files or network share, etc., you need an on-premise data gateway, which is a lightweight service that securely facilitates connections between Power BI in the cloud and your internal data. Install the gateway on a reliable server, register it to your tenant, and assign it to the workspace or the dataset. The gateway supports clustered mode for high availability. Don't run the gateway on a laptop. Use a server class machine and put it behind appropriate monitoring. Next, let's discuss about the credentials and privacy levels. In the dataset settings, you will set the data source credentials. Make sure credentials are valid and use service accounts when possible rather than personal accounts. Review privacy levels if used for proper data handling of joint data. When credentials fail, your refreshes will error out. The refresh history gives you the failure message to diagnose. Now let's move into incremental refresh to scale large datasets. For large tables, use incremental refresh to avoid reloading entire tables every time. Incremental refresh allows you to partition time-based data, refreshing only recent partitions and keeping historical partitions static. A huge performance win. To use it, you typically define range start and range end parameters in Power Query and enable incremental policies on the dataset in the service. This feature is essential on large datasets and often paired with premium or PPU capabilities for higher limits. Now let's discuss the refresh limits and quotas. Be aware of refresh limits related to license type. Free workspaces have limited refresh options. Pro and PPU have larger quotas, and Premium provides the most frequent and larger model support. If you need many hourly refreshes across many datasets, premium capacity is usually required. Now, let's go through troubleshooting refresh failures, which is a practical flow. So, check refresh history. The dataset settings page contains the refresh history and no error messages. Note timestamps, error types, and affected tables. Next, we have verify credentials. Test data source connections in dataset settings, update passwords or service account tokens as needed. Then we have gateway status. Confirm the gateway is online and on the latest version. If the gateway is offline, refreshes will fail. Check gateway logs and network connectivity. Timeout and query issues. If refreshes timeout, look at query complexity, break down running transformations, or push transformations to the source. Consider aggregations or move heavy transformations upstream. Next ahead, we have concurrency and capacity. If many datasets refresh simultaneously, the queue can delay refreshes, stagger refresh schedules, or scale capacity. Use the Premium Capacity Metrics app to monitor the saturation. Followed by that, we have data schema changes. If the source changes column names or data types, our query steps can break. Maintain communication channels with data owners before source updates. Now let's go to some advanced options. Refresh templates and cascading refresh, which is from Fabric. So for complex pipelines with semantic models and data pipelines, you can orchestrate refresh templates or chain refreshes so upstream data flows refresh before downstream data sets. This gives more reliable end-to-end data refresh in advanced architectures. Now let's go through an example scenario. Let's imagine a retail company imports daily sales. They use the incremental refresh policy to update only the last 14 days each night and a smaller hourly refresh during business hours for the previous day's rolling window. The gateway connects to their on-premise POS database and the admin monitors refresh failures via the refresh history and capacity metrics. The design reduces load, improves freshness, and keeps costs predictable. Now let's dive into the part D, which is about sharing reports and dashboards with teams and people. So publishing is one thing, sharing is where insights drive action. Power BI provides multiple sharing patterns. Choose the pattern that matches your audience, governance, and licensing. Now let's go through the sharing options overview. Workspace access. You can grant user roles inside a workspace. based on viewer, contributor, or member, or even admin. Use this for collaboration where users may edit or test the content. Next is publish an app, best for distributing polished, read-only content to many users in one go. Apps are versioned and provide a stable entry point for consumers. Next is the share option. The share button lets you send a direct link to the specific people or groups. This respects dataset RLS and requires recipients to have appropriate license or access. Use this for ad hoc distribution. Followed by that, we have embed in Teams. Add reports as tabs inside Teams, channels, or chats so users access analytics where they work. Embedding in Teams keeps collaboration seamless and can include comment and chat integrations. Next, we have secured embed or public embed or publish to web options. Secure embed option is for internal portals with authentication. Publish to web produces an anonymous public link. Use with extreme caution. It is used rarely for internal data only. Secure embed respects permissions with row-level security. Public embed is not. Now, let's dive into embedding in Microsoft Teams. So let's go through the practical flow. To add a report to a team channel, open the channel, click the plus icon, select the Power BI tab, then pick the Power BI report or dashboard you want to embed. The Teams tab gives users direct access to the report without leaving Teams, and you can pin it for quick visibility. This is a strong pattern for operational teams that already use Teams for daily communications. Next comes the row-level security and sharing. When sharing, ensure RLS is configured if recipient should only view a subset of the data. RLS is defined on the dataset and enforced by the service. It travels with the dataset and applies to all sharing mechanisms, including apps and team tabs. Use RLS carefully and test via view as a role to confirm behavior before wide distribution. Now, let's go through external sharing and B2B. You can share with external users via Azure AD B2B. Tenant admin must enable external guest settings. For customer-facing scenarios, consider Power BI Embedded, which is app owns data, to avoid provisioning licenses for external users. Always follow your organization's tenant settings policies and consult compliance teams for external data sharing. Now, let's go through best practices when sharing. Use apps for broad audiences, package reports and dashboards into apps with controlled permissions, and publish app updates rather than republishing workspace content. Next is document expectations. Every app report should include data refresh schedule, owner contacts, and intended use. Protect sensitive data. Use sensitivity labels and tenant settings to restrict export printing or sharing where needed. Training and adoption is the next step. Create short walkthroughs inside Teams or pin documents so business users know how to navigate reports and filter correctly. Next comes an example. The HR analytics team publishes a headcount and attrition app. They deploy it to the HR app workspace, run RLS so managers see only their teams, and add the app as a tab in each manager's team channel with a pinned frequently asked questions tab. Managers receive an email when the app updates, and the HR team monitors usage metrics to iterate. Now, let's dive into the part E, where we will discuss about embedding reports, approaches, authentication, and permissions. Now, let's go into part E, where we have embedding reports, approaches, authentication, and permissions. Embedding is where Power BI becomes a part of product experience and workflows. There are two main embedding models, and each has different security and licensing implications. Embedding for your organization where users own the data. This is internal embedding where the end user needs to authenticate with their Power BI credentials. The report respects their permissions and row-level security. Now, let's go through some use cases. Intranet portals and internal web apps where only authenticated employees access the analytics. Authentication typically uses OAuth with delegated permissions only. Now let's go for another one, which is embed for your customers, where the app owns the data. This is an external model where the application authenticates using a service principal or master account and renders reports to the end users who don't have Power BI accounts. This is the recommended approach for ISVs and SaaS apps. It requires Azure setup, which is Power BI embedded capacity, and careful security design. Use the REST APIs with a service principal to acquire embedded tokens for the client app. Next comes authentication options for embedding. User authentication, which is delegated. Users sign in with Azure AD. The embed respects their direct permissions. Use this when users already have Power BI licenses. Next is service principal, where we have only the app. It is recommended for app owns data scenarios. You can create an Entra app, grant Power BI API permissions, and use the client ID plus secret to authenticate server to server. Generate embed tokens with the REST API and pass them to the front end. This approach lets you control which reports a user can see without giving them the Power BI account. Now let's go through embedding methods and security trade-offs. So the first one, secure embed code or iframe. It is good for internal portals. It respects Power BI permission, but still requires users to sign in. It's the simplest path when you have basic embedding needs and internal authentication. Now, the next one is Power BI Embedded, which is dealing with Azure. It provides an Azure based hosting capacity for external embedding with higher scale and performance guarantees. You manage capacity, scale units, and the costs at Azure level. This is the correct choice for commercial products. Now, let's go through Publish to Web. This one creates a public, anonymous embedded URL. You need to avoid this for internal or sensitive data. It is effectively public. Use only for fully public or non sensitive visuals. Next is about permissions and row level security in embedding. When using user owns data, RLS continues to work as usual. Each user sees the data according to their role. When app owns data, you often need to implement row level filters at the embed token generation step to ensure each customer or tenant sees only their data. Use the REST API's embedded token generation and specify effective identities or RLS filters to restrict data. Test extensively. Now, let's go through practical architecture for ISV where app owns the data. Provision Power BI embedded capacity in Azure. Create a service principal in Microsoft Entra and grant it to the required Power BI API permissions. Use your backend server to call the Power BI REST API to authenticate, create or refresh datasets as needed, and generate embed tokens. Securely hand the embed token to the client browser for rendering via Power BI JavaScript software development kit. Rotate secrets and monitor usage and errors. Embedding example, secure internal portal. A company builds an internal vendor portal where each vendor can log in and view their performance dashboards. They choose secure embed with user authentication. Vendors authenticate via SSO and the portal uses an iframe or direct embed to render Power BI reports. RLS ensures each vendor sees only their data. The portal does not store embed tokens for long term. Now let's go through developer and security checklist for embedding. Use TLS and secure cookies. Rotate service principal secrets for every 90 days or use certificates. Log all token requests and embed activity for audit. Use throttling, retry patterns, and circuit breakers for REST API calls. Monitor capacity usage to prevent throttling or excessive cost. Embedding turns analytics into part of workflows and products. Choosing the right embedding model is a balance between user experience, cost, and security. And with that, we dive into part F, which is about permissions, governance, and tenant settings. Security and governance are the core. Power BI tenant settings and workspace roles provide guardrails. Tenant level governance. Administrators can set tenant wide policies such as allowing or blocking external sharing, enabling or disabling publish to web, managing who can create workspaces or use premium features, controlling which users can export data or reshare data reports, controlling which users can export data or reshare the reports. Work with the Office 365, Entra AD, and Power BI admin teams to create sensible defaults that align with corporate policy. Data sensitivity and protection is our next point. You can use Microsoft Purview sensitivity labels if available to tag datasets and reports. Labels travel with content and control export, print, or copy behavior. Pair sensitivity labels with tenant export controls to limit data exfiltration. For regulated data, consult data protection officers and legal counsel. Now, let's go through permission best practices. Let's start with least privilege. Only give the permissions that users need. Group-based access is the next one. Use Azure AD groups to manage workspace membership rather than assigning permissions to individuals. Next is service accounts. Use dedicated service accounts for schedule refreshes and APIs, not personal accounts. After that, we have audit and monitoring. Enable audit logs and review sharing patterns. Watch for unusual exports or public links. Now, let's discuss governance example. Finance publishes financial dashboard but restricts export and sharing. The tenant disables publish to web globally, and the finance workspace requires two admins and enforces certified datasets only. This ensures sensitive financial data is controlled and traceable. Now, let's have a quick closing summary and practical action plan. Let's summarize the core takeaways. Publishing moves your .bbix into Power BI service as a report, dataset, and query recipe. Choose the right workspace and connection mode before publishing. Workspaces are the primary collaboration and governance container. So use roles and developer to quality analyst to production patterns to manage content lifecycle. Dataset refreshes is critical for data freshness. Use gateways for on-premise resources, incremental refresh for large tables, and monitor refresh history for failures. Sharing should be intentional. Apps for broad audiences, workspace access for collaborators and team, embedding for everyday workflows, respect RLS and security. Embedding has two main models: user owns data, which is internal, and app owns data, which is external. Choose according to the licensing and business needs, and secure via service principals and embed tokens for app owns data scenarios. So, now let's discuss an action plan for learners. Publish a sample.pbix to a developer workspace, inspect the dataset, refresh it manually, and configure scheduled refresh options. Create a small workspace with member and viewer roles, publish an app, and install the app as an user. Now you can add a Power BI tab to the Teams channel and embed the report. Test the filter, add comments. If you have a developer background, you can generate an embed token using a service principal for test app. Work with your tenant admin to understand your organization's tenant settings and refresh quotas. Recommended reading and resources: publishing and uploading Microsoft Docs, Workspace and role guidance, Power BI docs on new workspaces, schedule and manage dataset refresh, Power BI refresh docs, embed in Teams, documentation and embedding Power BI and Microsoft Teams, embedding APIs and service principal guidance, Power BI REST API docs. That wraps Module 9. In the next module, we will cover report optimization, large model strategy, and best practices for performance tuning in Power BI. Now we enter Module 9, which is about Power BI tips, tricks, and common mistakes. So, in this module, we are moving beyond the basics and intermediate skills. We are focusing on the advanced habits that make Power BI users truly efficient, reliable, and professional. If you think of everything we have covered so far: data loading, Power Query transformations, modeling, DAGs, visualizations, and publishing, these are the building blocks. Module 10 is where we refine these blocks into a professional analytics system that is fast, scalable, consistent, accurate, easy to maintain, easy to understand. This module is important because most Power BI performance problems, business confusion, or dashboard failures don't come from Power BI itself. They come from avoidable mistakes such as poor modeling, incorrect tags, unnecessary visuals, or inefficient refresh processes. So, in today's session, we will go deep into performance optimization tips, avoiding common DAX pitfalls, best practices for dashboard design, using Q&A visuals, and smart narratives for storytelling. By the end, you will have a complete mental toolkit that will help you build dashboards like an enterprise level BI engineer, not just a casual report creator. So let's begin. The first section will be about performance optimization tips. Performance optimization is one of the most underrated skills in Power BI. Many users think performance issues only come from large datasets, but that's not entirely true. A poorly designed model with even moderate data can cause slow refresh, visual loading delays, memory overflows, frozen interactions, slow DAX measures, and many more. So, let's go step by step through the most important optimization techniques. So, the first one: reduce the model size. A lighter model loads faster, refreshes faster, and easier to maintain. So here comes the tip one. Remove unnecessary columns. Many datasets come with 100 plus columns, but typically only 20 to 30 are actually needed for reporting. So if you want to go through some examples of columns that you can remove, so some of the columns that you can remove are the columns which are only used for intermediate calculations. Audit fields like created by, updated by, columns with extremely high cardinality where you only need aggregates, pre-text comments, descriptions, or log columns that duplicate information like multiple versions of dates. Every unnecessary column increases refresh time. Removing even 10 such unused columns can significantly reduce model weight. Now, the next step. Reduce data cardinality. Cardinality means the number of unique values in a column. High cardinality is equal to slow performance. For example, a column with 1 million unique customer IDs, a date time column with timestamps for every second, a text field where every value is unique. All this creates pressure on Vertipack engine. Now, let's go through the optimization techniques. You can convert the date time data type, date f minutes, seconds that are not needed. Reduce precision of numerical values. Group or bin data where possible. For example, if you have multiple ages, then you can segregate them into a group from minimum age, that is 18 to 30, 30 to 60, and beyond. So you have three groups here. Avoid using GUIDs in visuals, avoid using unique IDs in slicers. Reducing cardinality improves compression and speeds up calculations. Now, the third tip, disable auto date time. Power BI has a feature called auto date time which automatically generates hidden date tables. For small projects, it's fine, but professional BI models, it should always be turned off. Why, you ask? Because it silently adds extra tables, which increases model size, relationship overhead, memory usage. Instead, always create your own date table marked as date table. Now, the fourth tip, use star schema for better performance. The most powerful optimization is correct modeling. A star schema ensures cleaner relationships, faster DAX evaluation, smaller models, predictable performance, and a lot more. In star schema, fact tables store numeric transactional data. Dimension tables store categories like product, region, or customer data. Many performance issues occur because users build flat tables or snowflake models with long chain. So, you need to consider one rule of thumb. One fact table connected to multiple dimensions is always faster than multiple flat tables. Now, the fifth tip, limit the number of visuals per page. Every visual is a query. Having too many visuals slows page Having too many visuals slows page load, increases memory usage, reduces responsiveness, increases dataset refresh time for direct query models. Recommended limits. Standard reports 6 to 12 visuals per page, executive dashboards 4 to 8 visuals, highly interactive pages 1 to 3 visuals plus slicers. If you need more, create drill down or drill through pages, bookmarks, or tooltips instead. Now, the sixth tip, avoid using too many slicers. Slicers may look simple, but they're expensive. Each slicer refreshes the entire page every time the selection changes. Replace slicers with drop downs, filter panes, drill through, filter report level, filters, buttons, or bookmark navigations. Only use slicers when user genuinely needs to make frequent selections. Now we have the tip number 7. Use measure tables. Professional Power BI reports separate measures from data tables. A measure table organizes calculations, improves model clarity, reduces accidental misuse of columns, enhances DAX performance because measures are calculated on demand. Never store measures inside fact tables. Now we have our next tip, which is about optimizing DAX. We will cover DAX mistakes in the next section, but performance optimization is deeply tied to DAX efficiency. A poorly written DAX formula can slow the entire model. For example, using SumX on large tables when sum is enough. Second example is using calculate unnecessarily. After that, we have using filter on entire tables instead of just few columns. Overusing all except, and remove filters is also one of the good examples. Great performance comes from minimal efficient formulas. Now, the ninth tip, avoid using many calculated columns. Calculated columns increase the model size, and these are computed at refresh time and are often found to be slow. These are usually replaceable by measures. You can reduce performance for composite models as well. Only choose to use the calculated columns if the logic cannot be handled by measures or a simple Power Query. 90% of calculated columns actually belong to the Power Query, not DAGs. Now, the 10th tip, use aggregation tables for large models. For very large datasets, millions to billions of rows, Power BI supports aggregation tables. Aggregated tables pre calculate high level summaries, reduce calculations, improve direct query performance, make dashboards more responsive. This is commonly used in finance, manufacturing, and IoT analytics. Now, let's have a short recap of the section 1. In summary, performance optimization is not one thing, it's a combination of disciplined habits. Following these practices ensures smooth dashboards, reliable refresh cycles, and scalable models. Now, let's go to the section 2 of Module 10, which is about avoiding common DAX pitfalls. This is one of the most important parts of today's module. Knowing DAX is one thing. Knowing how to avoid DAX mistakes is what makes you a true BI professional. So, the DAX issues almost always lead to incorrect numbers, confusing visuals, wrong totals, slow performance, incorrect filters, and a lot more. So, let's walk through the biggest pitfalls and how to avoid them. Now, the first one is misunderstanding row context versus filter context. This is the number one mistakes new users always make. Row context applies to each row in a table. Filter context, on the other hand, comes from slicers, filters, or calculate options. You must always remember a calculated column has row context, a measure does not. This is why formulas behave differently. Now let's go through some examples. Sum of sales of revenue. In a calculated column, this gives the same value on every row. In a measure, it changes based on visuals and filters. Misunderstanding this creates endless confusion. Now, the second one, overusing calculated columns instead of measures. Many beginners use calculated columns for everything because they behave more like Excel formulas. This leads to bloated models, slow refresh rates, memory inefficiency, incorrect aggregations, and a lot more. Always ask, can this be done with a measure? If yes, then always prefer a measure. Now, let's go to the third one, using calculate even when not needed. Calculate is powerful, but many people use it unnecessarily. For example, calculate sum of sales of revenue. This is pointless because sum already respects filter context. Only use calculate when you want to change the filter context. Followed by that, we have using filter on the entire table. Example, let's consider a mistake where you added calculate function of sum of sales revenue and then you added a filter for sales region, which is equals to east. Instead of using this, you can simply write calculation method inside sum of sales revenue and sales region is equals to east. Now this filter adds row context, slow, and column filters are faster. Now let's go through the fifth one, misusing all method, removing filters and all except. These functions remove filters, but many users apply them blindly. Now let's consider an example mistake. So here total revenue is equals to calculate sum of sales revenue and all sales. This removes all filters, even date filters. This particular approach removes all filters, even date filters. Always think which filters should remain, which filters should reset. If you want only a specific filter to be removed, be precise. For example, all sales of region, not the whole table. Now, let's go through the sixth mistake. Improper time intelligence calculations. Tax time intelligence requires a continuous date table, no gaps, a mark date table. If your date table is incorrect, functions like same period last year, total year to year, which is total YTD for short, date add, these functions will return incorrect values. Now let's go through the seventh mistake. Using earlier instead of variables. Earlier is an outdated and confusing function. Instead, use variables. An example is VAR current value equals to sales revenue, return current value, previous value, etc. Variables improve readability, improve performance, prevent repeated calculations, reduce mistakes, and a lot more. Now let's go through the eighth one, not using divide function. Divide handles division by zero gracefully. Now let's consider a bad usage. For example, sales of revenue divided by sales of quantity. So for a better approach, you can use divide method, sales of revenue, comma, sales of quantity, comma, 0. Always use divide method to avoid errors. Now let's go through the ninth one, ignoring DAX query plans. Power BI has tools like DAX Studio, Vertipack Analyzer, Performance Analyzer, and a lot more. These reveal expensive measures, slow queries, heavy tables, and a lot more. Professional BI engineers always test performance before deploying large scale dashboards. Now, let's have a quick recap of the section 2. DAX mistakes usually come from misunderstanding context. Once you master context, your formulas become faster, cleaner, and more reliable. Now, let's dive into the section 3, which is about best practices for dashboard design. In this section, we will shift from performance to design, the user experience portion of the Power BI. A dashboard is only as good as its design. Users should be able to look at your dashboard and instantly understand. The user should be able to understand what's the story, the trend, the insights, the action plan, and a lot more just by looking at your data dashboard. Now, let's look at some of the best practices that professional always follows. Now, the first one, apply the 5-second rule. A well designed dashboard should make sense within 5 seconds. If the user needs to scroll, zoom, decode, guess, or mentally calculate, then the dashboard has already failed. Dashboards must deliver insights quickly and cleanly. Now, the second one is avoid chart overload. Not all charts are equal. Avoid some charts, for example, 3D charts, donut charts with more than 4 circles, pie charts comparing similar values, clustered bar charts with too many categories, maps with too many points, etc. Instead, you can prefer bar charts, line charts, matrices KPI cards, scatter plots for correlation, decomposition tree for root cause analysis, waterfall for financial analysis, and similarly, we have other options as well. Simplicity always wins. Now, let's go with the third one, maintain visual hierarchy. Visual hierarchy means guiding the viewer's eyes. Use large fonts for key KPIs, bold colors for important numbers, consistent placements, white spaces, grouping and alignment, and these things are to be considered. Use large fonts for key KPIs, bold colors for important numbers, consistent placement, white space, grouping, and alignment. A clean dashboard reduces cognitive load. Now, the fourth one, use consistent formatting. Consistency builds trust. Use the same number formats, colors, decimal points or decimal places, date formats, naming conventions, and etc. For example, if revenue is in millions, keep it in millions everywhere. Now, the fifth point, keep colors meaningful. Avoid random colors. Use consistent meanings. Let's consider green for good, red for bad, blue for neutral, and yellow for a warning. Avoid too many colors. Try to keep it within a limit of 3 to 5. Now, let's go with the sixth point. Use tooltips for depth, not overcrowding. Tooltips help keep dashboards clean. Instead of adding extra visuals, add details to tooltips. Use report page tooltips. Provide drill through options. This keeps the main dashboard. Provide drill through options. This keeps the main dashboard minimal but yet powerful. Now comes the seventh point. Use bookmarks for navigation. Bookmarks can create guided stories, step by step narratives, collapsible filter panels, interactive instructions, and a lot more. Bookmarks often elevate dashboards into apps. Now, the eighth one, hide the complexity from the user. Always design dashboards so that actions are intuitive, slices are minimal, visuals are self explanatory, navigation is almost effortless. The goal is to deliver insights, not complexity. Now we dive into the section 4, which is about Q&As, visuals, and smart narratives. This section focuses on Power BI's AI-driven storytelling. This section focuses on Power BI's AI-driven storytelling tools. These tools help users ask questions and generate insights automatically. Now the first one, Q&A visual. The Q&A visual allows users to type natural language questions like what are the total sales by region in 2024, what are the top 10 products by profit, monthly revenue trend for a specified country, etc. Now, Power BI interprets these questions and generates the chart automatically. Now let's go through the best practices. Use proper field names, create synonyms, build a glossary, train the Q&A engine, and use the suggested questions only. This makes dashboards conversational. Now, let's move into the second one, which is about smart narratives. Smart narratives automatically summarize the trends, outliners, key insights, differences, and anomalies. It generates text that explains what the charts show. For example, revenue is increased by 12% in Q4 and it is driven by strong performance in the electronics segment. This adds storytelling to dashboards. Now, let's go to the third point, narrative customization. You can customize smart narratives by adding your own text, highlighting key metrics, creating dynamic summaries, linking measures. This ensures that executives can read insights in plain language. Now, let's go to the next one, which is storytelling with Power BI. A great dashboard isn't just a collection of visuals, it tells a story. A story should answer what happened, why did it happen, why is it important, what should you do next. Smart narratives plus Q&A plus bookmarks plus drill through create powerful storytelling experiences. Now, the conclusion to this particular module. Module 10 wraps up all the advanced principles needed to build enterprise level Power BI dashboards. We covered optimization techniques for high performance, DAX mistakes and how to avoid them, best design practices, AI driven storytelling, and a lot more. These skills will significantly improve the speed, clarity, and impact of your dashboard. In the next module, we will conclude the course with advanced deployment and governance best practices. So, welcome to the final module of this Power BI full course for beginners. In this chapter, we are going to do three major things: recap everything you have learned across the 11 chapter journey, provide most reliable resources for going advanced, and third one, give you a complete roadmap to crack the PL300 Power BI Data Analyst certification. So, by the end of this module, you'll have clarity on how data flows through Power BI, how each module contributed to building your Power BI skill set, what you should practice for next, and exactly how to prepare for the industry recognized certification. So, let's begin with the detailed recap. Chapter wise summary recap starts now. Chapter 1 recap, Introduction to Power BI. In this chapter, we laid the foundation for your entire Power BI journey. We started by understanding what Power BI actually is, not just as a tool, but as a complete ecosystem for business intelligence. We discussed the importance in 2026 and beyond, especially as companies shift from manual reporting to automated data driven cultures. You learned that Power BI is composed of Power BI Desktop, where you build reports, and Power BI Service, where you publish and share the reports, Power BI Mobile, where the leaders consume the insights on the go. You also explore the real world use cases of Power BI, marketing team analyzing campaign performance, sales teams forecasting revenue pipelines, finance teams automating MIS and dashboards, HR teams monitoring employee performance and hiring metrics, operation teams optimizing supply chains and logistics. Finally, you installed and set up Power BI Desktop, preparing your environment for rest of the course. Now we dive into the chapter 2 recap. You have understood Power BI workflow here. This chapter explains Power BI's end-to-end workflow, which mirrors how organizations actually use the BI. It all starts from data, next to transform, next to model, then visualize, then publish and share, and lastly automate. We broke down each layer. Data sources like Excel, CSV, SQL Server, cloud services, transformations using Power Query, where we did the cleaning operations, modeling, where we established relationships using star schema, visualizations, where we created interactive and insightful charts. Then comes the publishing, where we uploaded the dashboard to Power BI service, sharing and governance using workspaces, permission, and apps. By understanding this workflow early on, you were better prepared for the practical steps that followed. Now we dive into the chapter three's recap, which is about connecting to data sources. Chapter 3 was your introduction to real data ingestion. You learned how to import Excel and CSV files, pull data from the web, connect live to SQL Server, understand the difference between import mode and direct query, understand dual mode and when to use each. We discussed real life scenarios like import mode for faster dashboards, direct query for real time analytics, live connections for enterprise semantic models, etc. We also learned how businesses often deal with multiple systems, ERPs, CRMs, marketing systems, and how Power BI acts as a central reporting layer. Now, with that, we come into the chapter 4 recap, which is about data transformation with Power Query. This was the most important modules in the course because 80% of the data issues happen before the modeling stage. In chapter 4, we explored the following: Power Query interface, applied steps pane, query settings, data types, transformation, and add column ribbons. We also went through cleaning operations such as removing null spaces, null values, handling errors or replacing errors, filtering unnecessary rows, standardizing data formats, and a lot more. We also did some transformations where we merged queries, join operations, appending tables, splitting columns into multiple fields, pivot or unpivot operations for reshaping data, etc. We also covered why Power Query's M language is powerful for automation. Once you build a cleaning process, Power BI can rerun the same steps every time a new data arrives. Now, with that, we dive into Chapter 5's recap, which is about data modeling. Chapter 5 introduced to the heart of Power BI, the data model. You learned relationships, primary keys and foreign keys, one-to-many versus many-to-one cross-filter directions, schemas, and a lot more. We also dealt with schemas such as star schema for the best practice, snowflake schema and when to avoid it, lookup tables, how dimension tables helps you slice data, why fact tables contain measurable values, why hiding unnecessary columns improves the model, and finally, you learn how the model affects performance, DAX calculations, reports interactivity, and long term scalability. This chapter gave you the structural backbone of your reports. And now we dive into chapter 6 recap, which is about introduction to DAX. This chapter was your first deep dive into data analysis expressions, the formula language behind the Power BI. You learn calculated columns versus measures. Columns are row by row measures that are aggregated at query time. Measures are recommended for calculations involving filters. We also went through some common DAX functions such as sum, calculate, filter, all, distinct, count, divide, and a lot more. We also went through time intelligence functions like year to date, month to date, same period last year, date add, etc. We discussed practical business scenarios as well. For example, calculating year on year growth, computing conversion rates, creating running totals, generating customer cohorts, and a lot more. This chapter gave you the analytical depth required to turn raw data into insights. Now, we also discussed the recap of chapter 7, which is about visualizations in Power BI. This was your storytelling chapter. You learned core visuals, bar and column charts, line and area charts, maps, pie charts and donut charts, KPIs and cards, and a lot more. We also learned formatting skills like removing clutter, customizing colors and labels using themes, adding drill throughs and tooltips, and we also implemented filters, slicers, visual level filters, page level filters, report level filters, and a lot more. You also learned how professionals make dashboards intuitive, minimalistic, insight focused. Your dashboard started to look polished and business ready. Now, with that, we dive into the recap of chapter 8, and this was about time saves dashboard project. This chapter was the hands on real world project for you. You worked with a sample data set and performed data cleaning, data modeling, measure creation, visualization building, bookmarks, and UI design. You created sales KPIs, trend charts, region-wise sales performance, category-level insights, and a lot more. You designed an executive view, an interactive drill down, a modern UI layout. By the end, you had built a complete industry-grade sales dashboard. Now, this brings us to Chapter 9 recap, which is about Power BI service, publishing, and sharing. This was your introduction to Power BI and the cloud. You will learn how to publish reports, how to create and manage workspaces, how to refresh datasets manually or automatically, how to share dashboards securely, how row level security ensures data protection. You also explored embedding and permissions, which are essential for enterprise rollout. Now, this brings to the chapter 10 recap, which was majorly about tips, tricks, and common mistakes. In this chapter, you gained production level experience, performance optimization, avoiding large cardinality columns using star schemas, minimalizing visuals, disabling unnecessary interactions, and a lot more. We also learned about DAX pitfalls, misunderstanding row context versus filter context, using calculated columns when measures are better, relying too heavily on iterators, dashboard designs, best practices, consistent colors, proper visual hierarchy, fewer slicers, meaningful titles and tooltips, and a lot more. We also dealt with AI features like Q&A visuals, smart narratives, text-based summaries for executives, etc. This chapter helped you transition from a beginner to a professional level Power BI developer. And now you're ready for Power BI certification and professional growth. So now we will go through the section 2 about this particular model, which is based on the resource guide. So the first resource that you will be going through is the Microsoft Official Learning Resource. The Microsoft Learn Power BI collection from beginner to intermediate to advanced topics. This particular guide covers data modeling, DAX fundamentals, Power Query, Power BI service, row level security, deployment pipelines, and a lot more. You can search this particular resource online. You can just type Microsoft Learn Power BI and you'll have the resource. The second one is Power BI official documentation, the most updated resource for Power BI visuals, DAX functions, data gateway configuration, Microsoft Fabric, and Enterprise BI. You can search online and you can type Power BI documentation from Microsoft and you'll get the resource. The third resource is Microsoft Power BI blog. This is perfect for staying updated on monthly feature releases, new visuals, performance improvements, and industry announcements. Now comes the resource number 4, which is about Microsoft Fabric plus Power BI integration guides. This helps you understand lakehouses, warehouses, one lake, AI powered BI workflows, etc. Now, the last one, which is the Simplilearn learning resources. You can go through Simplilearn's Power BI tutorial, which is free, and to get this, you can search online. You can type down Simplilearn Power BI tutorial, and our videos break down complex topics in beginner-friendly formats. You can also go through Simplilearn's Power BI full course, which is available for free on YouTube. This particular resource is useful for revision, especially for tax basics, data modeling, and dashboard building. Apart from this, you have Power BI certification material by Simplilearn. To get this, you can go to a browser and search Simplilearn PL300 and you will have access to structured content mapped to exam topics. Now, let's go through the next section of this particular module. Now, let's go to the next section of this particular module, which is about PL300 certification roadmap, a detailed step-by-step industry recognized preparation blueprint. So firstly, what exactly is PL300? PL300 or Microsoft Power BI Data Analyst is one of the most in-demand BI certification in 2026. It validates your skills in data preparation, data modeling, data visualization, tax analysis deployment, and sharing. The exam focuses heavily on practical business-oriented BI scenarios. PL300 skills measure the first one, prepare the data 15 to 20%, get data from different sources, clean, profile, and transform data using Power Query. The second one is model the data, 30 to 35% weightage stays here. You need to design star schemas, create relationships, optimize the model, implement row level security. The third stage is visualize and analyze the data. 25 to 30% weight stays here. So you need to build dashboards, create measures, add advanced analytics visuals, apply filters and interactions. Then comes the fourth stage where you deploy and maintain the assets. 20 to 25% weightage stays here. You need to publish report, set up workspaces, configure refreshes, manage permissions. You've already learned all these topics throughout this course. Now, let's go through the detailed study roadmap for 4 to 6 weeks. Let's start with the week 1. Power Query plus data preparation. Focus areas: import modes, merging, appending, pivot and unpivot, working with data types, removing errors. So you need to practice, and the practice is take 3 to 4 messy datasets from Kaggle. So you need to practice for this. The practice might include taking 3 to 4 messy datasets from Kaggle or public data, clean them entirely using Power Query. The goal is to build muscle memory in transformation logic. Now comes the week 2, data modeling, the most important week. The focus areas: star schema relationships, cardinality lookup tables, model optimization. The practice: build at least 3 models from scratch, identify fact versus dimension tables, create a semantic model report. The goal is you should be able to design a model on paper with confidence. Now comes the week 3, tax mastery. The focus areas: row context versus filter context, calculate all except iterators, sum x, and time intelligence. You need to practice. Write at least 20 to 30 measures, calculate year to date, year on month, create KPIs, etc. The goal: you must be comfortable with calculate and context transitions. Now comes the week 4, visualizations plus Power BI service. The focus areas are building dashboards, drill through, bookmarks, tooltips, publishing reports, and workspace management. You also need to take care of dataset refresh and row level security. For this, you need to practice. You need to practice creating a polished report, publish it, set up schedule refresh, add row level security. The goal: you should be able to present a full report end to end. Now comes the week number 5, revision week. Plus, you can also have some mock tests as well. So, you need to use Microsoft's Learn practice questions, Simplilearn's practice questions, Microsoft practice assessments. The focus areas here are rereading DAX functions, reviewing modeling diagrams, practicing service related flows. The goal: achieve 80% in mock tests. Now, let's go through some recommended learning approach. You can use Power BI Desktop daily. Try building dashboards from any dataset you see. Practice explaining your report. This helps for interviews. Follow Microsoft blogs monthly for new features. And now the wrap up and motivation you were looking for. You've completed one of the most comprehensive beginner to advanced Power BI journeys. You now understand data ingestion, data transformation, data modeling, data analytics, dashboard storytelling, cloud publishing, performance tuning, and a lot more. And now with the module 11, you know where to go from here. The best official resources, the certification roadmap, and the job ready skills that you must practice. Whether you're stepping into BI, upgrading your analytics career, or preparing for PL 300, you now have the foundation and clarity to move forward with confidence. And with that, we have come to an end of this session on Power BI Will Course. If you have any queries regarding any of the topics covered in this session, or if you require any of the resources used in this session like PPT, data source, or core segments, then please do let us know in the comment section below, and our team of experts will be happy to assist you at the earliest. Until next time, thank you for watching and stay tuned for more from Simply Learn.